Good morning, herzlich willkommen. Soyez les bienvenus. Thank you for joining. It is 11 a.m. in Brussels and Berlin, and we are live on Zoom and YouTube. The German National Academy of Sciences, Leopoldina, and the German Research Foundation DFG welcome you to the International Virtual Conference, Genome Editing in Europe, New Agenda or New Disputes, on the occasion of the German Presidency of the European Union Council. My name is Lucian Brujan, and I work with the Leopoldina's International Relations Department, and I will be your host for the two first webinars. This conference takes place as a series of, in total, 5 webinars, today and tomorrow. Warm greetings to our conference panelists, outstanding experts in their fields, joining us from Germany, Belgium, the Netherlands, Argentina, the US, Japan, Finland, Switzerland, Canada, and Australia. Thank you so much for accepting our invitation. Greetings to the almost 500 attendees connected live across the globe and throughout the time zones from almost 40 countries. Before we get started, just some brief technical remarks. If you wish to ask a question, please use the question and answers feature in Zoom, the Q&A. You will find it down in your screen on the control board. And please send us your questions. We and a team of people who are in the background and are taking care that everything works smoothly, we will collect all your questions, summarize them, and feed them into the panels. In each panel, there will be place for questions and answers. If you want a question to be assigned to a specific panelist, just kindly ask to indicate the name. Feel free to share your tweets and postings on this conference using the hashtags Genome Editing, DFG, and Leopoldina. We now open the conference with 3 messages, and I welcome Professor Gerald Haug, President of the Leopoldina. Gerald Haug is a paleoclimatologist and geologist, and he's director of the Max Planck Institute for Chemistry in Mainz in Germany, and also professor for climate geochemistry at the Swiss Federal Institute of Technology, ETH in Zurich, Switzerland. Professor Haug, you have the screen.
Thank you, Lucia. Dear Katja Becker, dear Mrs. von Krambrun-Taubadel, dear Mr. Burcher, dear Mr. Franken, dear Mrs. Jülicher, ladies and gentlemen, representatives from policymaking, science, civil society, and business. I warmly welcome you to this conference organized by the German Research Foundation, the DFG, and the German National Academy of Sciences, Leopoldina. Thank you for joining us today and tomorrow from across the globe. My sincere gratitude goes to the experts from 10 countries for their willingness to share their expertise with us and engage in this undertaking. Genetically modified organisms, GMOs, and genetic engineering in plant breeding are an obvious hot topic. Often the public debate, however, lacks differentiation, and we end up in a divided landscape. This is where our conference steps in. We want to insert unbiased and factual knowledge in the debate in the spirit of co-designing public policies. We want to look forward into the future and to explore openly and inclusively all options on the table, not just evidence, but also analysis and dialogue with all relevant stakeholders. This is what we consider scientific advice. Ladies and gentlemen, the precautionary principle enables decision makers to adopt precautionary measures when scientific evidence is somewhat uncertain and the stakes are high. It is also our approach to new technologies in Europe and frames the answers to 4 important questions. How do we want to deal with new technologies? How do we weigh up benefits and uncertainties of such technologies? How do we design a regulatory frame which minimizes risks? How do we use empirical knowledge to amend, tighten, or relax regulation? More than 2 decades, there have been so many different interpretations of the precautionary principle that we have to de facto a paralyzed debate, call it a non-debate. Science and practice now have access to revolutionary technologies which question most of our traditional approaches in regulating genetic engineering. These are far more precise and cost efficient than any known before. These are the so-called genome editing tools. What is the consequence? It has become urgent to find the proper regulation for the application of their products. After all, how can we regulate technologies whose products may be indistinguishable from natural variations? Should the outcome of technology be the focus of regulation rather than the technology itself? And what about the implications on plant breeding? The relevance of efficient breeding for agriculture is undisputed. Agriculture is one of the EU's heavyweight policy areas and common agriculture policy. Just look at the numbers. In 2018, the EU has spent 37% of its budget on farming, 58 billion euros. Even after a planned decrease after 2021, still it is an impressive amount if we compare it, for example, with the Horizon Europe budget. Food production both faces and causes enormous challenges. It is both threatened by climate change and it accelerates global warming. At the same time, we see an unprecedented decline of biodiversity in the agricultural landscape. On this latter aspect, next month, Leopoldina will release recommendations for the improvement of this critical situation. We need a change here, and we need it now. The European Commission recognizes the importance of these problems and addressed it in the Farm to Fork strategy, which, I quote, lays at the heart of the European Green Deal. We strongly welcome the European Green Deal under the leadership of Commission President Ursula von der Leyen and hope to see the first results soon. Ladies and gentlemen, today we discuss the transformation of the food production system. Which role can GMOs in genome editing plants play for a sustainable agriculture? How should we assess the socio-economic and environmental concerns? How should we tie up the loose ends? Tomorrow, we will widen our view and take on a global perspective. We will see how countries that are important exporters of agricultural products on the world market deal with new breeding technologies. We will see where the European Union stands globally. Finally, dear Katja Becker, my sincere appreciation to you personally and to the DFG for this fruitful cooperation. Many thanks to the Leopoldina DFG organizing team as well for this endeavor. I wish you all an insightful and targeted debate, even under those special circumstances, which is asking for much flexibility and creativity. Thank you and stay healthy.
Thank you, Professor Haug. Thank you very much. I welcome the next speaker, Professor Katja Becker, President of the German Research Foundation, the DFG. Katja Becker is a physician and biochemist holding the chair of biochemistry and molecular biology at the University of Gießen in Germany. Professor Becker, the screen is yours, please.
Yeah, thank you very much. Dear Professor Haug, dear Dr. Franken, Director General Böttcher, Director Jülicher, members of the European Parliament, colleagues, friends, and distinguished guests. It is such a pleasure to welcome all of you, also on behalf of the German Research Foundation, to this 2 days conference on the regulatory framework of genome editing on a European level, as well as the related scientific debates. Leopoldina and DFG, Gerald Haug just mentioned this, share really a long-standing tradition of collaboration in many areas of scientific policy advice. And this conference is the ideal way to continue this beautiful tradition. I wish to express my sincerest gratitude to Professor Haug and the team from the Leopoldina for co-hosting this meeting. It is my greatest hope that researchers and policymakers are going to use the next 48 hours to share perspectives and exchange opinions, and that this exchange will enrich, indeed, the public debate. Listen to the science. It is very fortunate that this slogan has gained momentum with respect to the unprecedented crisis that we are facing, from the ongoing pandemic to climate change to biodiversity loss. More and more people choose to actively support policies and actions that contribute to protecting the climate and the natural environment, for example. Research on climate change and biodiversity has played a decisive role in this context and is increasingly gaining public recognition. However, research on agriculture and food security does not enjoy the same level of public improvement. Agricultural scientists and plant geneticists often experience distrust, especially if their findings appear to deviate from long-held beliefs. This may be linked to the widespread narrative telling us that we can make agriculture environment-friendly and solve the problem of hunger and malnutrition by simply employing the romantic ideal of agriculture in pre-industrial times. That this produce less by using extensive production methods. This belief is commonly held in Europe and beyond. All you need to do is to add a bit of urban gardening to the image of the 19th century. If you choose to listen to science, you will find that this is not going to work, unfortunately. If we want to realize progress and tackle the challenges agriculture is facing globally, we will need something more sophisticated than a degrowth strategy. A modern plant breeding approach will have to play a key role in this context. The field of agroecology also has to offer a lot. Cover crops, no-till farming, and intercropping all have their merits and are increasingly incorporated into so-called conventional agriculture to realize intensification in a really sustainable manner. What we need to allow for a well-informed agricultural policy, as the EC is striving for with its farm-to-fork strategy, is a comprehensive assessment of such approaches using criteria that must include not only crop yield, but also nutritional value and environmental impact. All aspects of sustainability, in other words. This conference we are looking forward to aims to contribute to this discussion. In order to inform regulatory approaches, we are going to explore what new breeding technologies have to offer, as well as possible unintended side effects. The adverse impacts of the climate crisis are increasingly adding to the problems that agriculture is facing. Climate change does not only bring about droughts and detrimental heat, it also promotes the spread of all sorts of devastating pathogens. Over the next few decades, we will have to produce significantly more food and other plant-based products globally in order to contribute to meeting the Sustainable Development Goals, despite all of these challenges. Moreover, we will have to achieve this on a less land and using significantly smaller amounts of fertilizers and pesticides. So what can new breeding technologies contribute, and what are the issues? There are three different levels that we will have to disentangle to allow for fruitful discussions. First, are crops originating from NBTs safe and healthy for consumers? Second, what are the environmental risks and maybe benefits? And third, what about their socio-economic implications? All of these three levels must be taken into account, making the best possible use of the diversity of scientific, political, and geographical backgrounds represented at this conference. NBTs are certainly not a silver bullet that will solve all the problems agriculture is facing. However, banning the use of modern technology will make it even harder to master the challenges ahead. The ways in which NBTs should be regulated is a matter for society as a whole, rather than just the academic world. Let us therefore strive for an even better informed public discussion, because the issues at stake are urgent and challenging indeed. I hope that these very important topics will be transformed into intellectually stimulating questions over the next 2 days. Thank you all for your contribution, and may we all experience very insightful discussions. Thank you.
Thank you so much, Professor Becker, for your words. I now welcome Dr. Lorenz Franken on behalf of the German Federal Ministry of Food and Agriculture, Minister Julia Klöckner, who cannot join us live today. Lorenz Franken is an international expert on bio and genetic engineering, and he's currently director of the Department Consumer Health Protection, Nutrition and Product Safety in the Federal Ministry. He has been working very closely with Minister Klöckner and in several leading positions within the ministry since 2002. Dear Dr. Franken, you have the screen, please.
Dear Ms. Becker, dear Mr. Haug, colleagues, ladies and gentlemen, please let me first convey my minister's regards. Indeed, your work and the exchange with you are particularly important to her. Why is that? Well, the Federal Ministry of Food and Agriculture is responsible for people's life issues: nutrition, safe food, and agriculture. With these issues in particular, today we are faced with a challenge that we have become mired in ideological discussions in many areas. And many people have become entrenched in their views and have forgotten how to conduct a dialogue. But this approach is not getting us anywhere. That is why we need a willingness to talk to one another and to seek compromises. With today's event, you, the scientific community, are actively addressing current genetic engineering issues. New impulses from science, such as your current statement on genome-edited plants, are indispensable for social and political discourse. What expectations do we have of genome editing today? Well, it is remarkable indeed that there are different expectations not only between, but also within various social groups. And it is no secret that even within the German government itself, we are still having an intensive discussion about a responsible approach towards this particular topic. The widely disparate opinions are important for political discourse and have their value within democracy. Politics, business, and science, we must all take into account people's diverse opinions. But while broad discussions take time, advances in breeding research are rapid. For decades, random mutations have been used for breeding according to the principle of trial and error. While this often resembles searching for a needle in a haystack, genome editing allows us to process genetic material in a much more targeted way. Using new genomic techniques, we can indeed speed up breeding processes massively. According to your recommendation, already mentioned, time savings of up to 50 years are possible, depending on the specific technique. We could use this time gain wisely in fields where the need for innovation is particularly high. As already mentioned, climate change impacts such as drought, food shortages, or the loss of biodiversity call for urgent action to be taken. As I said before, the impetus and work of science and industry is important, always bearing in mind that the results of research have to be fed back into society, providing a benefit to all. So how can we realize the potential of new technologies most effectively? At present, genome-edited plants are regulated as GMOs in the European Union. The current legal framework is more than 20 years old. Actually, some of its core part go even back to the 90s. I personally can remember very well the entering into force of the directive on the deliberate release, because that was the time when I finished my doctoral thesis about 20 years ago. And evidently, since then, many things have changed. For instance, and most unfortunately, my hair has turned gray. Well, some might wonder, how is that related to today's discussion? Actually, I do not want to compare the state of EU biotic law to my hair color. Anyway, I think we should very, very thoroughly check whether EU biotic law still properly reflects the interplay between the precautionary principle and the need for innovation. In my opinion, the precautionary principle is a valuable asset. But we must also take into account the current state of science when applying it. With regard to new breeding techniques, many scientists argue that the risk assessment of a modified plant depends not on the tool used, but on the specific characteristics of the organism. Or in other words, new legislation should look at the product, not the process. On the other hand, there are voices who consider the current regulation as interpreted by the European Court of Justice to be appropriate and sufficient. From this point of view, efforts should be focused merely on the tracing system for new breeding techniques. Between these opposing poles, the Commission is currently preparing its study on new breeding technologies, a very challenging and nevertheless exciting task. Congratulations, Ms. Jülicher. The study will be presented next spring. I am looking forward to its outcomes and the Commission's suggestions, and I think you all are too. We as a society have the responsibility to negotiate how we want to use new breeding techniques, and I think we should start negotiating today. That is why I have a few questions for you. First, as scientists, what specific benefits do you believe genetic engineering can provide to society as a whole? Secondly, in retrospect, we must ask ourselves whether genetic engineering has so far met the expectations placed in it. Do you see improvement in this field? Thirdly, do you recognize any uncertainties that we must counter with the precautionary approach, also to counter people's worries? And ultimately, as part of the scientific community, how do you see your role in the discourse? I am convinced that in view of the global challenges, it is our responsibility as a society to objectively analyze how we want to use new technologies. We cannot afford to ignore new technologies. We should use them on our terms for a sustainable and efficient agriculture and food industry. Finally, I wish you a successful and very fruitful event, and thank you very much for your kind attention.
Thank you very much, Dr. Franken. Many thanks to the three high-level speakers for opening this conference and for your encouraging messages. We take inspiration and bonne chance, as you say it in French, from your messages for the next 2 days. Because we are a bit late, we are in Germany, we stick to the schedule. We proceed with the first session entitled Scientific Advice on Rethinking EU's GMOs Regulatory Framework, which will be moderated by Professor Justus Wesseler. Justus Wesseler holds the chair in agricultural economics and rural policy at the Wageningen University and Research in the Netherlands, working on bioeconomy and policies. And I welcome also the two panelists in the session, Professor Martin Quein and Professor Hans-Georg Dederer. Martin Quein is Professor of International Food Economics and Rural Development at the University of Göttingen in Germany. And Hans-Georg Dederer holds the chair of Constitutional and Administrative Law, Public International Law, European and International Economic Law at the University of Passau. Both panelists were part of the Leopoldina working group on risk assessment and regulation of genome edited plants. And That is the group that co-authored together with experts nominated by the DFG and by other German science academies the statement towards a scientifically justified, differentiated regulation of genome-edited plants in the European Union. Justus Wesseler, I give the screen to you.
Yes, thank you. Dear Professor Haug, Professor Becker, Dr. Franken, Mr. Bujan, representatives from the European Commission, European Parliament, scientists, policymakers, stakeholders, colleagues, friends that are joining us today, we will discuss a very important issue. The study by the Leopoldina and DFG has already been mentioned. In that study, important aspects of new plant breeding technologies for societal benefits have been raised. There's also been raised the issue that the benefits might be more difficult to achieve based on the current regulatory system that we observe in the European Union. Now, in this session, we will reflect on some of these aspects. We have two renowned speakers. They have been already introduced. They will present their views. We will have the two presentations one by one.
There seems to be a problem with Justus. Do you copy us? If not, I propose to Justus, are you online? We are in the digital age. Yes, you were just. Okay, please go on.
I don't know how much you could follow what I have said and where I did stop because I was interrupted and don't know exactly what happened. But I give the floor to Professor Keim to start with this presentation. Please.
Thank you, Justus. I'll share my screen. And I do have 12 minutes to explain why GMOs and other new plant breeding technologies can contribute to sustainable development and why the European regulatory approach is inefficient and not science-based. So let me start right away by giving you a brief insight into the challenges for food and agriculture, not only from a European perspective, but from a somewhat global perspective. We cannot ignore the fact that hunger and malnutrition is still widespread. Around 25% of the world population do not have access to sufficient calories and nutrients. There's still widespread poverty and vulnerability to poverty, and this is very closely linked, often the same types of persons. But it's also important to know that most of the world's poor and undernourished persons are actually small-scale farmers in developing countries. So they depend on agriculture not only as a source of food, but for their livelihoods. That's the situation as it is. If we look into the future, there will be further demand growth for food and other agricultural products, including for the bioeconomy. And this is happening at a time when we are more and more aware of the planetary boundaries. Of course, we have to clearly see that food and agriculture have huge environmental and climate footprints. These lead to environmental change, climate change, biodiversity loss. And these are not only externalities, but they're negative feedbacks. We know that climate change is already and will further affect agricultural production negatively, and especially so in the tropical and subtropical regions where many of the poor and undernourished people live. So there is the risk and the danger of rising poverty, rising malnutrition if we don't act in a more sustainable way quickly. There's widespread consensus that to make food systems more sustainable, we need major types of transformations. And there are no quick fixes. There are no isolated solutions. We certainly have to act in various ways and following various steps at different levels. It would be naive to expect or believe that agricultural technology or plant breeding could solve all these problems. but it would also be irresponsible not to see that science and technology and plant breeding in particular has at least quite a bit to contribute to many of these different things that we need to urgently address. So let me zoom into plant breeding, and here you see a list of some of the different methods that have been developed and used over the last 12,000 years since the beginning of agriculture. You see, as we move further down in this list, we're getting to more and more precise and efficient and quick breeding types of technologies and methods. And in any other field of science and technology, such spectacular progress would be very welcome. Take medicine, take mobility, take energy. Not so obviously in food and agriculture. There we do have different standards from public perceptions. And we are seeing that there has been in the framing of the public debate an artificial divide. There, everything above this dotted line is now called conventional breeding. Everything below is called genetic engineering and GMOs. Now, it's not only about the labels we give something, it's about conventional breeding is widely perceived as natural and safe, and GMOs are widely perceived as unnatural and risky. And this is also exactly the current EU regulatory approach that differentiates and asks GMOs for very, very different types of tests and regulations. And this, in spite of the fact that over 30 years of risk research are telling us that GMO crops are safe, they're safe for human consumption and the environment. There are no new or no other types of known risks, and therefore there's also no reason to treat them differently in terms of regulation. This is about environmental and health risks. But of course, one may argue there are other things that matter for sustainability. There are social concerns that many people in the debate attribute to high-tech farming. We're observing increasing use of chemicals. We're seeing less and less diversity in monocultures, increasing farm sizes. Many are concerned about patents on life that may contribute to monopolies. In short, we're seeing what's often termed industrializing or industrialization of food systems. And yes, many of these things are real and they are indeed problematic from different sustainability perspectives. But in the end, we need to be careful where's the real cause, and is it really not too simplistic to assume that all new types of technologies will inevitably aggravate these issues? Or can we perhaps use science and technology and develop it further to address and solve some of these issues? Let's look at the potentials of gene editing. I mean, much of the work of the last years and decades has actually moved into developing crop plants that are more resistant to pests and diseases, or that are more efficient in terms of nitrogen and phosphate. So they can work in terms of reducing agrochemicals. Yes, previously, traditional plant breeding approaches over the last couple of decades have been focused on a relatively small number of different species. But here now with gene editing, we are seeing actually work already in more than 40 different species. So diversity could be brought back. It's something that's working with the seeds that all farmers, including small farmers, are using. Gene editing is relatively cheap and can also be used by small labs, by public organizations. So it could bring back competition and diversity into seed markets if efficiently regulated and managed. And of course, that's a big if. And that's why we are having this conference. Now, let me bring you another example that's showing clearly that it's not the breeding method as such that's creating impacts, but it's the way we're using it, the types of crop traits that we're developing and how they're integrated into agricultural systems. let's look at some of the evidence we have on the GMOs that currently exist. They have been adopted widely in more than 25 different countries over the last 30 years. Unfortunately, we're only talking about two types of traits, insect resistance and herbicide tolerance, while other traits have been developed. They've not been approved due to overly precautious regulatory approaches. But let's look at these. These are data from a meta-analysis of all the 200 or so different studies that have been carried out. We're seeing, yes, both of these traits, insect resistance and herbicide tolerance, do contribute to higher yields and higher farm profits, but we also see a major difference, namely insect resistance that's contributing to reductions in chemical pesticides, herbicide tolerance, rather to an increase. So can we say that GMOs do contribute to lower pesticide use? No, we can't, but there are certain applications that do and others that don't. So it depends on the trait. There are also other differences. Insect resistance crops are used by all types of farmers, including smallholders in countries such as India, China, South Africa, and so on and so forth. Herbicide tolerance so far is almost exclusively used by large, fully mechanized farms, partly in monocultures that are not sustainable. So there are differences in how things and technologies are being used. And of course, we need serious debate about what types of agriculture we want and need. But blocking useful technologies that can do very different types of things is certainly a very inefficient and non-science-based approach. Let me get a bit more specific on why the EU GMO regulations as they currently stand are problematic. I've already mentioned that singling out transgenic and gene-edited crops as inherently more risky than conventional crops ignores the state of science and research. But this is also further fueling public fears and misunderstandings. Policymakers often say, well, we don't want to approve them because the public is concerned. But well, with this regulatory approach, the public certainly must feel more and more concerned. So there's this mutual reinforcement. Well, there are technologies that cannot be used in Europe for farming, and some may argue, but if they're so safe, they will run through all those safety tests, so why can they not be used? Well, it's a very politicized process, and many of you may know, and others may need to know, that since 1998, no single GMO has been approved for commercial cultivation in Europe. So more than 20 years. So it's effectively a ban. The current regulatory approach is a ban on GMOs, but not only on the applications, it obstructs research, of course, because also field trials need to be approved. And if you do applied research, at some point you need to move out into the field in order to test whether something works and is safe, but you can't under the current regulatory conditions. It jeopardizes the international competitiveness in terms of agriculture, in terms of crop research, and the bioeconomy. And also important to know, I mean, young researchers are really disincentivized. I mean, there are many who are considering a career in plant biotech, but they are saying, well, I don't want to work in a field that's treated with so much hostility in the public debate. So they're turning to other fields. But this is Europe. I mean, Europe, however, is rich. And we could say, well, we can afford that. Perhaps nothing too bad happens. But this does have international consequences, and we need to be aware of them. In other parts of the world, gene-edited crops are not considered GMOs. And that can cause really international trade disruptions, because the European Union is an important player, is also an important importer in international agricultural and food trade and germplasm exchange. And everything that has been using gene editing is actually has to be approved and regulated, not only for cultivation, but for import. Any gene-edited crop, unless it contains foreign DNA, and most of the gene editing applications so far don't contain any foreign DNA, they cannot be detected. this leads to problems. I mean, what are other countries and regions doing? Either they say, well, we stop trading with the European Union and we move forward with the technology, but that's unlikely to happen for many countries because the EU is an important importer. The second possibility could be, well, we continue trading with the European Union, but we stop using gene editing. So nothing would happen elsewhere in the world as well. Or we continue trading with the EU, but when it comes to gene editing, we are running through that regulation, but that's a possibility that only large companies have, that only the multinationals have, and they will only do it in large commercial crops and trades. So it would lead and does lead to market concentration, and that's exactly what we would like to actually prevent. I am particularly concerned also about the implications that our regulatory approach has for Africa and Asia, because they look a lot into what the European Union is doing, and they need new agricultural technologies for sustainable food security the most urgent, and this is why we need reform of the European regulatory approach. Thank you.
Justus, are you with us?
Yes, I always move in and out when a presentation stops. So, Professor Keim, Martin, thanks a lot for your presentation. We now directly move to the second speaker, Professor Dederer from the University of Passau.
Thank you very much, Mr. Chairman. I would like to share my screen as well, so I'll try to do that. Okay, now you should see the screen, and I will start my presentation, which is a presentation on the scientific recommendations by the German science academies and the German Research Foundation. And these recommendations are published in a statement issued by the Leopoldina and the German Academies of Sciences and the German Research Foundation. And the statement is titled "Towards a Scientifically Justified Differentiated Regulation of Genome-Edited Plants in the EU." That is the title of that publication. What is the background to this publication? This was the ECJ judgment of July 25, 2018 in the case Confédération Paysanne and others. The court was asked to answer certain questions submitted by the French Conseil d'État, and these questions concerned the interpretation of Directive 2001/18, which is also often called the GMO Directive. And in brief, the questions were: first, are mutagenesis organisms genetically modified organisms, GMOs? And second, what is the scope of the mutagenesis exemption? To understand these questions, we have to briefly look into the structure of Directive 2001/18. And this structure actually is fairly easy. There's a front door, and the front door, that is the GMO definition, which means any organism that is covered by the GMO definition is a GMO. That means it passes the front door and is inside regulation. There's also a back door, and that is the exemption clause. And GMOs, which are inside regulation, may escape from regulation by passing through the back door. So there's a front door and a back door, and the back door is defined by certain techniques, and among these techniques is the technique of mutagenesis. So this is why I call this the mutagenesis exemption. The court answered these questions asked by the French Conseil d'État in the following way. Regarding the GMO definition, the front door, the court chose to construct this definition, to construct the front door broadly. Meaning that all mutagenesis organisms, all organisms resulting from mutagenesis are GMOs. past the front door, are inside the regulatory framework for GMOs. By contrast, the court chose to construct the exemption, the back door, narrowly. Of course, the exemption applies to mutagenesis exemptions. However, it does not apply to techniques of mutagenesis which have appeared and have been mostly developed since that directive was adopted, and that was on the 12th of March 2001. The court was a little bit more precise as regards these techniques, methods of mutagenesis. This can be derived from the reasoning of the court and the facts of the case. So according to the reasoning of the court and the facts of the case, these are techniques of directed mutagenesis involving the use of genetic engineering. And by way of example, the court refers to these two techniques, oligonucleotide directed mutagenesis, in short ODM, and site-directed nuclease mutagenesis, in short SDN. And these techniques, ODM and SDN, are those techniques we call genome editing. So what follows from the judgment is that genome-edited organisms, at least ODM and SDN organisms, are GMOs that are regulated, that are not exempted from regulation. And that means all rules on deliberate release, placing on the market, labeling, and traceability of GMOs apply also to ODM and SDN organisms. And this is so irrespective of whether the genetic modification could have occurred naturally or could have been obtained through traditional breeding techniques. And this is what scientists concerned most, that the regulation of organisms depends on the breeding technique. So one organism is covered by regulation, but another organism which possesses exactly the same genetic modification is left unregulated simply because the genetic modification occurred by nature or was obtained through some so-called traditional breeding technique. And this prompted the Leopoldina to establish a working group, and it did so together with the German Academy of Sciences and the German Research Foundation. The Leopoldina established an ad hoc working group on regulation of genome-edited plants, and these were the members of the working group. And as you can get from their affiliation, the members came from highly diverse scientific disciplines, so it was an interdisciplinary working group. In December 2019, just after about 1 year of several rounds of discussions, the working group issued that statement titled "Towards a Scientifically Justified Differentiated Regulation of Genome-Edited Plants in the EU." And this is here the front cover of that statement. And what is published in the statement are several recommendations, namely 7 recommendations. First, to amend existing GMO legislation. It's a short-term recommendation. In the long term, however, to adopt a completely new legal framework. Then, third, to facilitate field trials, to discuss breeding methods in a more differentiated, nuanced way, to ensure free choice, for example, of consumers, farmers, to exploit the potential of innovations responsibly, which means also taking into account the precautionary principle, for example, and finally, to increase market competition. Well, as a lawyer, I will refer to the first 2 recommendations, starting with recommendation 1, the amendment of existing EU GMO legislation. The objective of such an amendment should be that genome-edited organisms are exempt from GMO legislation only if they do not contain foreign genetic information or do contain a combination of genetic material which could have occurred naturally or obtained through traditional breeding methods as well. The means to achieve these objectives are either to narrow the front door, that means to narrow the GMO definition, option 1, or to broaden the back door, which lets GMOs escape from regulation, that means to broaden the exemption, option 2. Now let me refer first to option 1, which is the amendment which leads to a narrowing of the GMO definition. And as you can see here, these are least invasive amendments in the end. So the GMO definition should read as follows. GMO is an organism in which the genetic material is altered in the shape of insertion of genetic information into the genome in a way that does not occur naturally by mating and or natural recombination. What is the idea of these minor amendments? Well, the idea is to clarify the original meaning of the definition. The original meaning is that a GMO is not only constituted through the use of certain techniques. What constitutes a GMO within the meaning of the directive is also the result achieved through the use of these techniques. So what matters is not only the use of certain techniques, but also the result of such techniques. And this should be clarified by this new wording, but in the end, it's simply clarifying the original meaning of the GMO definition. It was never considered to be purely process-based, but also to be result-based. The second option is to broaden the exemption clause and the backdoor that is defined by certain techniques, among them mutagenesis, as you already know. And the suggestion is that we leave the definition as it is, but we broaden the backdoor through adding to the list of techniques the following techniques. Targeted molecular techniques, which when applied, effect a genetic modification that may have occurred naturally, in particular, techniques that cause deletions of DNA, exchange individual base pairs, do not cause stable insertion of genetic information, or cause the insertion, inversion, or translocation in the genome of genetic information known to occur or that could occur with high probability in the natural gene pool of the same species or closely related species. My last slide concerns recommendation 2, the adoption of a completely new legal framework, which means a complete revision of the current legal framework. And this is due to the question, what are the sources of risks to human health and the environment? And scientists, I think, agree that it is the sources of risk are not or is not the process of genetic modification, but it's rather the product and its traits and the use of such products which pose or may pose risks to human health and the environment. Therefore, from a scientific point of view, the new framework should be product-based, which means the regulatory trigger, what triggers regulation, should be the novel trait of an organism. And further, this framework should ensure legal certainty, which means what needs to be implemented is a consultation mechanism, the purpose of which is to clarify the regulatory status of organisms. Are they organisms which possess novel traits and are covered by regulation, or are they organisms which do not possess novel traits, which are then left unregulated? Finally, of course, the framework should be science-based, which means, for example, that any risk assessment should be adapted to traits and their novelty, and the evaluation, and every 5 years, an evaluation of the legal framework should take place. I would like to stop here, and thank you very much for your kind attention.
Yes, thank you very much, too. We had 2 excellent presentations, one addressing the potential benefits from new plant breeding technologies, and the second one addressing possibilities for reforming the current EU legislative frameworks for approval. Now, let me first ask one question, and that is more directed to Professor Keim, as it addresses more the economic issues. Why is it that the European Union approval process is so much generating so much complications, other countries are also regulating GMOs. They may have somewhat different regulatory frameworks, but they also look into this. So what makes Europe then unique? Why is the European regulation creating a problem?
Thanks, Justus. This is an important question. It's the politicized process. We have a regulation in Europe that foresees that, first of all, certain tests have to be run through, and then scientists and experts in EFSA look into this, and they form an opinion. But in the end, it's politicians of the European Commission that have to make a decision. And the politicians from the different member states, they often make decisions not based on what EFSA says and what scientists say, but they make decisions on what they believe is popular in their member countries. And we do unfortunately have that situation that there is widespread skepticism and distrust, and therefore there's evidence that various researchers, including your group in Wageningen, have done showing how different member countries vote depending on what EFSA is saying. And there are certain countries that always vote no, regardless of what the science expertise has said. And that's the politicized process that's much more pronounced in Europe than elsewhere. However, spilling over, I'm traveling a lot in Africa, and the Africans say, well, if Europe doesn't approve all those things, there must be something wrong with it. So we don't move forward. And there are many things that have been tested successfully in Africa and were never approved for exactly those reasons.
Yeah, thank you. Then I have a direct follow-up question to Professor Dederer. If this is so much a politicized process, how confident are you that the proposals that you have laid out may pass the political process?
Well, this is, of course, a very difficult question, and not directly a question to the law, but to politicians in the end. I'm quite aware, of course, that what we would need is an amendment to the current regulatory framework. That means we need an amending directive, and it means that this process must be initiated by the Commission, and that means in the end that the Commission must get convinced that such an amendment is really necessary right now. And but even if the Commission initiated such a process, of course, the legislator in the end is Parliament and the Council, and we need a majority in both organs, in the Council and Parliament. And I think there's quite a lot of work ahead, actually, for the legislator. And so the outcome, of course, is more than open, actually. So no one can really predict. But I think the legislator could actually vote in favor of that very minor amendments we suggested in that scientific statement. And I think it's possible, as you can see right now in the COVID-19 pandemic, that the legislator is able to act very, very quickly. I do not expect the legislator to act within 1 week like the German parliament did in spring, but I can imagine that within 2 years, actually, such a legislative process could be in the end carried out.
Yes, thank you. And it's good to know that we have at the following sessions representatives from the European Parliament, the Commission, and other stakeholders that take part in this kind of debate. So it will be nice to see what they have to say. But I also like to know whether or not there have been questions raised in the chat room, and what are those questions?
Yes, thank you, Justus. We are going to extend our session with 10 minutes, but we should finish by 10 past 12. So please, if you could respond in a concise way. There are many questions, and I will try to currently coming in one after the other. There are a few questions regarding the relationship between the European Union and other countries, especially Asia and Africa. One question to Professor Klein. Since the EU has banned de facto GM and gene editing technology, this affects obviously the cultivation of such crops in Asia and Africa. those people will be very reluctant to produce such crops because the EU market will reject them or there is no regulation. How do you comment on that? Shortly, if it's possible.
I would fully agree, and there are concrete examples. Virus-resistant papaya that was grown grown in field trials and close to being commercialized in Thailand many years ago, where under the threat from Europe to stop importing any fruits from Thailand, papaya or any other fruits. Made a complete ban, not only on virus-resistant papaya, but for a couple of years on all GMOs. So these things are real, and the European attitudes and regulations do affect countries in the developing world in particular.
Thank you. Just one short second. We have a few questions regarding how new regulation should look like, but more on the way to approach the whole thing. And there are two questions related to the so-called principle of comitology. It seems that we are stuck in comitology, and shouldn't we more focus on the direct involvement of member states, for example, like in the case of approval of new medicines on the level of the European Union?
Professor Degor perhaps can answer that best.
Well, I think this could be a new option actually, which would deviate actually significantly from the current regulatory framework. I'm not quite sure actually whether we should really follow this approach, which is the approach under drug regulation in Europe, because even that approach, when you talk to those people who are involved in this kind of process, even those are not lucky actually with this kind of process. So I think the centralized procedure, which also exists actually on the European level when it comes to new kind of drugs, the so-called ATMPs, there's what applies is a centralized procedure, also involving comitology. And so I think in the end, the centralized procedure should be kept actually also under any new legislation. I know the comitology procedure is a problem, and that was described by Martin Keim earlier today. The problem is if it's only the national regulatory authorities which decide on marketing of GMOs or genome-edited organisms, then the system is that other member states need to recognize this, and we will have exactly the same problems. And there will be member states who object any such recognition, which will object to any such recognition on the basis of grounds which I think will be often very political grounds, but not really scientific grounds.
Thank you. We have a policy representative here in our panel, so to say, Dr. Franken. How do you look at it, basically giving it back to member states and providing them more freedom to come up with decisions? How does the German government look at it?
Well, I'm somehow reluctant in joining the optimism just raised by Professor Dederer. Just if I try to answer the question from the German point of view, from the German perspective, the German vote related to the marketing approval of GMOs is well known. The German vote usually is the abstention, because we have still a lot of discussion and fundamental discussions on that within the government. Therefore, I'm not sure whether that approach would lead to a different result.
Okay, so that is a very skeptical view on this, perhaps also shared widely in the literature by others. But Dr. Franken, you have raised the issue of what can scientists do within this debate, and can they perhaps be instrumental for changing the current political situation? So may I ask Professor Haug to briefly respond on that, where he can see the possibilities for scientists to play a more political role in this debate.
Well, I can try. I'm obviously not an expert. I'm a climate person. But from the climate environment perspective, I think there will be a need to go for GMOs in the second part of the century, without doubt, to feed that 8 to 9 billion people. I think in general, a science-based approach in any of this discussion, a rational discussion, should be the fundament of decisions. And if this is well transported within policy making into the society from all of us, I think we can come to a new fundament for decision making.
Thank you. I also like to transfer this question to Professor Becker. Should DFG play a more active role in this, using the voice of science to influence policymakers? You are muted, sorry.
Dismute myself. Yes, yeah, thank you very much for this question. Yes, I think we are already quite actively involved actually in the communication with policymakers, but this is certainly an ongoing process, and we certainly continuously have to intensify these communications and this exchange, particularly because the environment around us in Europe, in Germany and in Europe, of course, and in the world is continuously changing, and also because the techniques and the technologies are continuously changing. So it is very important to stay in the contact, in the close contact and the close exchange. And maybe just to add this, I'm actually very happy that as the coronavirus crisis showed here in Germany, policymakers, decision makers, and society and scientists have been in very, very close collaboration and very close dialogue to be able to maneuver through this crisis. And I think it would be wonderful if we could extend this very fruitful experience also to other fields of research.
Okay, that would be then perhaps one of the positive implications of the corona.
One of the few positive ones, yes.
Thank you. Brujan, do we have another question from the audience?
We are running a little bit late, so if
one question.
One more question we will take from the panelists, from Professor Klein, Alexander Maria Klein. Question to Martin Klein. Do you have a comprehensive and weighted list of risks and advantages of different conventional and genetic engineering breeding methods? So the question is about methods and risks. Short answer.
You're muted.
New varieties can come with new types of environmental risks, and these need to be assessed. But by all the scientific insights that we have from the last 30 years, there's no indication whatsoever that the risk is related to the breeding method. So it is related to the outcome, the product of breeding, and not the process. And we are in no way making any statement in terms of get away with all regulation and risk assessment. Of course, we need risk assessments, but we should do that in a science-based way and follow the insights that we got over the last 30 years of research.
Thank you. Justus, if you just allow me, there are many questions in the Q&A channel. If all those presentations will be made available, I just want to say that all what is here is being recorded. The live stream on YouTube is being recorded, and in a matter of a few days, next week, to the end of next week, we will have all the sessions recorded on the DFG official channel, DFG Bewegt, and on the Leopoldina Vimeo channel, so on 2 platforms. That's all from my side. I give now the screen to you.
Yes, thank you. So let me summarize what we have discussed so far. We have seen that that these new plant breeding technologies, they offer a number of opportunities, that when we look at those new technologies from a national as well as international perspective, then we first observe that there are a lot of international relationships happening with respect to the policy regimes that European Union, but also that other countries apply. So there are substantial spillover effects. And in particular, if we look at the European political and regulatory environment, we observe that the regulatory approach that is used in the European Union seems to result in a number of obstacles for the private sector to invest in these new technologies, so that they may either move to other countries or do not invest in these new technologies at all. And so from that, we have seen there's a claim that there's an important overhaul of the current regulatory system needed. And I really like the approach by Leopoldina DFG to come up with some concrete steps how this can be done. We have also seen that that might not be easy, that within the policy debate, a proposal may not easily fly through, but I think it's important to have one to start the debate. And I think from that perspective, I like to congratulate Leopoldina and DFG for initiating this debate that we have today and tomorrow. And I really look forward to the other presentations that we will have today and tomorrow, also more from policymakers and other stakeholders involved, how they look at the specific issues, and hopefully that we then in the end will learn from this and move forward in a constructive way, also based on the positive experiences that we have made during the Corona crisis that seems to provide some more opportunities to come to common solutions. So from my side, thanks a lot to all the panelists, as well as to the audience that was listening and providing interesting questions. And now I hand over to Lucien Brujan for some final remarks.
Thank you very much. Just one sentence. Thank you for joining us after a short lunch break. Please join us again. We will have a high-level panel discussion with policymakers from the Commission, the Parliament, and the European Council, and representatives of business and farmers associations and science, which will start at 1 o'clock, so 1 o'clock p.m. Central European Summertime, GMT +2. Thank you very much. That's all for now. Bye-bye. We just have a small time to wait because we are streaming simultaneously in Zoom and in YouTube, but now everything seems to be working. I have a lot of thumbs up from the other side of this room. Okay, thank you very much for joining in. Good afternoon to everyone. Bon après-midi à tous. We are starting with session number 2, which will be a high-level panel discussion on the role and competitiveness of EU's research and development for sustainable agriculture. Please again use the question and answers feature in Zoom for addressing questions, which will be summarized at the end, and we will try to insert as many questions as possible. Not to waste time, I just introduce our wonderful moderator for today. Welcome, Marlene Fiaschi, Managing Director at Science Business. I think most of the people who are in Brussels know Marlene quite well. She has joined Science Business in 2011, and she leads the company's operation and growth strategy. But before that, Marlene has had an extensive experience in the European Commission itself, so she knows quite well what's happening in Brussels between the different stakeholders. Marlene, we are very, very happy that you are today with us. Warm welcome to the other panelists, and I hand the screen over to you.
Thank you, Löschen, and good afternoon to everyone. Thank you for the nice introduction. So for those who don't know, Science Business is a news and communications company specialized in research and innovation policies at the European level. And indeed, I will serve as moderator for this session that will look at the role and the competitiveness of the EU's research and development for sustainable agriculture. For those who haven't followed this morning's session, I suggest I just start with a quick word of context. Well, since the European Court of Justice ruled in July 2018 that modern precision genome editing or novel breeding techniques remain subject to the 2001 EU directive banning GMOs, the pressure to reverse the legislation have significantly increased. And as we heard in the previous sessions, the scientific community has pushed to rethink the EU's GMO regulatory framework. In fact, in the summer 2019, researchers from about 120 institutes around Europe said the EU's ban, and I quote, no longer correctly reflects the current state of scientific knowledge. So the statement is strong, and that's one of the things that we will cover with this panel. The European Commission is currently working on a study on the status of novel genomic techniques and the Union law, with a report due in April 2021. And as a result of this study, a proposal for a new legislation could possibly, and I said possibly, take place. So during this session, we will really be looking at the policy landscape. So we will run discussion as a policy discussion. And the objective is really to understand the state of play around the research on novel breeding techniques in Europe and understand their role or their potential role in the transition towards sustainable agriculture. So by crossing the views of policymakers, representatives from the industry and from the research community, we will aim through an open debate to better understand what is at stake here for Europe and really assess the odds of seeing the legislation on genetic engineering and resulting crops evolving in the coming years. So with this word of introduction, it is now my pleasure to introduce the 6 panelists that have kindly agreed to be here with us today. So first of all, Viola van Kramon-Taubadel, you're a German member of the European Parliament with the group of the Greens, European Free Alliance. We also have with us Wolfgang Böttcher, Director General for Agriculture and Rural Development at the European Commission. Also from the European Commission, Sabine Jülicher, Director for Food and Feed Safety, as well as Innovation in the Directorate General for Health and Food Safety, so European Commission. And we also have with us Petra Jorash, Manager plant breeding innovation advocacy at Euroseed, a trade association representing the voice of European seed sector. Pekka Pesonen, who has just joined us, Secretary General of COPA and COGECA, European Farmers Association, and finally Dirk Kinsey, Science Director of the Center for Plant Systems Biology at the Flemish Institute for Biotechnology at Ghent University. Ladies and gentlemen, thank you very much for joining us today. Before we kick off the discussion, just as Lucien mentioned, we will take questions from the audience, so don't hesitate to ask some questions. I promise that we will take at least some. I understand that the activity on the chat is quite intensive, but we will take a few questions, and you can also interact on Twitter, the hashtag of the conference being Genome Editing, or you can also use the two other hashtags, hashtag Leopoldina and hashtag DAG. With this, let's deep dive into the topic, and Yola, if you don't mind, I'd like to start with you. As you may have, as you will notice very quickly, since we are running that as a policy discussion, all the speakers kindly agreed that I address them by their first name. So thank you for that. So Viola, there is, one of the leitmotifs of this conference is very much to look at linkages between the different stakeholders. So plant breeding techniques are linked to research and innovation, also to sustainable agriculture, and also to consumer protection. And while we're still debating on the rightness of novel breeding techniques, we know that research and innovation have created or is still creating new results. At the same time, the agribusiness follows its own logic, and in parallel, consumers want more quality of agricultural products for the same price. Unfortunately, at this point in time, a common agenda is lacking. So my question to you is how to achieve such a common agenda?
Well, first of all, oh, sorry, it starts again. Thanks a lot for having me on this extraordinary panel. Since I was listening also to the first session, it is always very hard to speak after such distinguished experts, such as my team and the lawyer, the legal expert, and while they really try to figure out the pros and cons in a very structured and systematic way, while they also referred to the very politicized debate on one hand, which is of course right. So I think we have to also look what is the track record of the, I'm so sorry. What is the track record of the genome editing, and what is the track record of transgenetic experience? And what my team has, for example, focused very much on, and I can go align with it, that with genome editing, we really would have an improvement for smaller and also public organizations. But also, I think from the European Parliament side, I think we have to introduce better scrutiny instruments and also try to find out how to oversight really this research and maybe new common agenda when we would like to talk about. It's no secret that especially our group is very reluctant to have or to come along, to come out with a, let's say, new proposal for a GMO legal basis, especially because the precautionary principle and the non-GMO labeling is of utmost importance for the majority of the group, but also for many of the biological based and organic based farmers. So there is, let's say, a big a trade of let's say, the innovation part and how much in genome editing sort or genome editing breeding could be implemented as an organic. We have not even talked about that because, of course, this is not really an issue which is debated now and could then be also part of a real sustainable agriculture. While I see right now the reservations is absolutely great, and it's not just in our party, it is all over the society. And I think this is also important to say that the consumer preferences right now is very much, I think in Germany, it's even 3/4 very much against the use or the consumption of genome driven food, and that makes it very difficult to explain what is genome editing, what is the new or the innovation of genome editing, why is it different from transgenic sorts, and so what is the real progress, and why is it so difficult now to explain a little bit more in detail for the broader audience and for the consumers the non-detection of this new breeding and sort. So I think that many of the, let's say, reservations are rooted in what have Martin also mentioned, the patterns of life, monopolies, market monopolies, industrialized food systems. So if the innovative part of the breeding industry can really prove that the majority of the new breeding sorts would cover this public good and would really go into sorts which could contribute to malnutrition and could really give a solution for the question of food shortages and so on and so forth. This would maybe make a difference, but so far I think the social and economical questions are not really in the focus, are not really the priority of the commercialized breeding and sorts, and that makes it very difficult right now to even start a discussion.
Thank you. That sets the scene very nicely. You've raised a number of very important points here, so I think we'll come back to some of them a bit later, because the reality is that the European food system is embedded in the world market, and there are different ways of handling the question of GMOs and genetic engineering around the world. And Sabine, can I come to you, because one of the main issues that consumers have is indeed the potential role of GMOs on health, and agriculture, food and health are very closely linked. So can I ask you, well, how can we make sure, or first, how can we define a good regulation for novel agricultural products if we cannot detect the technology behind it? And one of the issues, or one of the differences around the world is in fact the disclosure of the use of these techniques. So what do you think? How can we define a good regulation for novel agricultural products?
Yeah, thank you very much. First of all, thanks for inviting me. Thanks for the question, and thanks for the opportunity for the European regulator to speak on the topic, because that's what we are in that sense. I mean, me and my colleagues, we are responsible for the authorization of GMOs for the European market. So maybe to give a bit of context here, as you rightly say, we have existing EU legislation. If I may slightly correct, the function is not to ban GMOs, but it is giving a frame to allow genetically modified organisms safely onto the EU market, which means, and there I come to your question on health, that prior to allowing these products on the market, we have a very, very thorough safety assessment, which is done on basis of science. It's a long process, it's a cumbersome process for the applicants, but it is a process that has, ensured that the GMOs we have on the European market, mainly for food and feed users in particular, that they are safe. So in that context, we have a framework. It's not the youngest, not the freshest, but it is an existing framework. And indeed, the court has confirmed in its ruling in 2018 that genome-edited products are covered by this GMO legislation. And I think that was also the moment when really the discussion was triggered. What does all of this mean? What does it mean for research? What does it mean for Europe and the possibility of Europe to use these techniques for various purposes? Now, you mentioned also the study that the Council has basically asked to the Commission. It's a very comprehensive study. It's ongoing. You're right, the results will be there in April 2021. But it is really there also to look into certain practical questions, one of which is, detection. How can we detect? But the concept of this study is much broader. It looks into, benefits, concerns, the ethical aspects, the robustness of risk assessment, also what are current and future scientific and technological developments. I mean, what are we seeing coming already onto the market in third countries, for example, and also concerning societal implication, ethical questions, and so on and so forth. So it's a very broad, very deep-going study, very much with the involvement of stakeholders and member states who have provided us with this mandate. And by April 2021, as I said, the study should be delivered. And the Commission may, if appropriate, present a legal proposal. I have to be very, very clear at this moment in time. The study is ongoing. We are doing this entirely open-minded. We want to see the results and the outcome. The decision on opening the regulatory framework or proposing something new and different is really still to come. So you had a very particular question on, detection, how important it is to detect the technology behind. That is indeed correct. We also mandated the European Union reference laboratories to look into that question, and they will deliver a series of reports. But what is clear, if we speak about a known DNA alteration, it is very well possible to develop detection methods. So detection in principle is feasible if we know what is the alteration. We also asked member states, because they are responsible for enforcement, also at the point of import, what is their experience, what strategies could there be. But I would also like to remind that experience from other sectors that we have in Europe, where you cannot detect with a method the claim or the content. For example, say origin indication. I mean, there is no method in the true sense to verify the origin of a product, but through other means like traceability, like paper trails, or in future we'll rather talk about blockchain, it is very well possible, to find an alternative system to a detection method. So I think that should help us for the future. And in this context, I mean, to bluntly answer your question about, a good regulation, not only for novel products, it should allow for innovation. It should allow for confirmation of safety, and safety in the widest sense. I may refer also to our recent strategy on the farm to fork for a sustainable food system. So we will be looking in future not only at safety, but also contributions to sustainability. And a good regulation, in principle, should allow, for these objectives to be met. It should allow also for Europe to be a place for research, for developing innovation. And I would not now really link it very, very firmly to the detection method or the ability of detecting, an alteration.
Very good. Thank
you.
You mentioned the Farm to Fork strategy, so it's time to turn to Wolfgang. The Commission with DG Agri in the driving seat has put forward its ambition Farm to Fork strategy. And again, this is what I mentioned before. It's about connectivity between different areas, between different stakeholders, between different topics. So the first question to you is a general question. How do you see the linkages between research and innovation on one side, but also plant breeders, farmers, and consumers, if Europe wants to be a champion here?
Thank you very much, Marilyn, and good afternoon to the colleagues, and thank you very much for your kind invitation. Indeed, the agriculture is facing quite some challenges. Agriculture is victim of the climate change. Just look at the loss of harvests in Romania this year. But at the same time, agriculture needs to become more sustainable because we also contribute to the deterioration of environment, biodiversity, climate. And the Farm to Fork strategy in that respect clearly indicates that farmers and agriculture has to contribute indeed to more sustainability. And you have seen the targets. It's about reducing risky pesticides. It's about using less fertilizer. And the question arises, what kind of research and innovation do we need to address these challenges? Because with our conventional methods, we will not really succeed. So I think everybody agrees that we require research and innovation to make agriculture more resilient, climate adaptation, but at the same time also to make agriculture more sustainable. So everybody agrees about research and innovation. And the Farm to Fork strategy has also indicated that new technologies need to be looked at in this context. And I think Sabine has just pointed out the procedure that will lead to this assessment. Now, I think what is extremely important for us is in agriculture is that for the reasons I have just indicated, I think research and innovation, including on gene editing, is very important because it might constitute a tool to address exactly the challenges which we are facing. At the same time, it's also a question of competitiveness of the agricultural policy for the reasons you have set out, Marilyn. Now, evidently, we will look very carefully at the results of this study, as Sabine has just pointed out, and the further action will depend indeed on the assessment of this research. But I would like to make 2-3 points. I think it's very good to have excellent science and research, and I know it from my former business. But that's only half of the story. And the other story is the point that Viola has referred to. Science needs to convince society and consumers, because as agriculture, we are also interested in that we have markets and people are buying these products. So I think it is really crucially important that we have excellent science, but certainly equally important to convince society of the possible advantages of these technologies, at the same time pointing out the risks if there are. Now, I think a key question in this further discussion will certainly be, and again I do not anticipate the result of the study, is really the question in the public debate, and science promotes that these techniques are solutions for many of the issues which we are facing, make agriculture more resilient. And I think it's very important that we can prove that this is true. And it's certainly interesting to see whether parts of these promises have been delivered with the conventional GMO techniques. I think somebody needs to be sure to say, listen, the new techniques, they might deliver better or even more targeted. So I think it's really important that this key element, that these new technologies need to be safe in terms of human safety, but also in terms of environmental impact is very crucial. And we need holistic approaches in this domain. So this is what I would say at this point in time. And
that's very good. Thank you very much, Wolfgang. Can we turn to the industry now? Petra, can I come to you? And so, yeah, you represent the plant breeding industry. There are already some novel breeding techniques that exist and that go far beyond the traditional ones or beyond genetic engineering. And you are, as an industry, you must be interested in remaining competitive or even in being more competitive. And obviously this is a legitimate interest. So what is the position of the industry when it comes to regulating novel breeding techniques in Europe?
Thanks, Marilyn, for the kind introduction, and thank you also for inviting me to this nice panel discussion. Yeah, indeed. So maybe I first introduce you a bit to the European plant breeding and seed sector. So it's a highly diverse sector and it's highly innovative. And why is it? What we see is our companies reinvest up to 20% of their annual turnover into research and development. And that's a huge amount of investments. And of course, they need to also recoup their investments from selling their respective products on the seed market. So the EU seed market is about 20% of the global seed market at the moment, and the breeding companies release around 3,500 new plant varieties per year to the European farmers, and that provides, of course, a wide variety of choice of crops for the farmers to be able to grow competitive products, also in view of the global market, of course. Nevertheless, we are a global sector as well. So, but we have, of course, local roots. We did an internal survey within our sector, where we asked our companies if they are active in using these new breeding techniques like genome editing, and 98% of the companies who replied to our questionnaire, which were 62 companies in total, they are acting on a global level. So they are either having R&D facilities in different parts of the world, breeding facilities, they do seed sales and seed production on an international basis. So this means we are an international sector, and of course, international competitiveness is key for us. So it doesn't make sense to only look into, let's say, the national or the regional legislation and regulations. A harmonized scope of regulatory oversight when we look at the global level is key for our sector. And this can also be seen, so 20% of the seed which is produced worldwide is traded somehow between different parts of the world. And so our companies are very much interested in this, let's say, harmonized scope of regulatory oversight, and how concretely do we look at that? And that was mentioned already in this first session this morning. So we have a pretty similar position like the scientific position which was presented by Leopoldina and DFG. So in our view, we should not differentiate by looking at technologies, but we should differentiate how these technologies are used and what the outcome of these technologies is. So having a look at a tool like genome editing doesn't make sense if you can use the tool in many different ways. It's the same if you would like to regulate the use of a hammer, for example. You can use it for putting a nail into the wall, but you can also use it to kill somebody. So you need to look at the outcome, and we have a very differentiated view. We say if the outcome is something which is similar to what you can also do by conventional breeding techniques. And we addressed the issue of detectability and for especially distinguishability already. Then it should not be regulated as a GMO, because in the end you could have two similar products. One would be regulated as GM, the other would be a conventional variety. So it would not make sense to regulate them differently. And so that's our positioning. And for that, we would also suggest a targeted amendment of the respective basic regulations, so the 2001/18 directive.
Understood. Thank you. We have two more voices to hear before we get into the group discussion. So can I ask the next two speakers to go with brief introductory remark? I'll just go to the farmers now, Pekka. So you're the voice of the farmers here. So I'll ask bluntly, do you see a role for genome editing in this transition towards sustainable agriculture?
Thank you very much for the invitation and opportunity to take part in this panel discussion. Indeed, well, that's an easy question for a farming community. Irrespective of what we want, this will be a part of the reality that we will be facing. And I find it very strange, also professional, and I'm an agronomist myself, and when we look at the recent discussion in the EU, we're quite disappointed for the fact that it is the EU and the Western nations in general that actually have created the abundance of food and green revolution. We actually sustain billions of people in the planet, and most of them actually have sufficient foodstuffs. And in this respect, now when the European Union has had the internal talks, especially some of these technologies, we find it irrational, in fact, from the European Union own perspective, that we do not actually value our own scientific work and the progress that we have shown over the decades. It doesn't mean that we are without criticism when it comes to the outcome, and that we need to be also realistic with. And that's why farm to fork and the biodiversity strategies are really important as part of the Green Deal and supporting the CAP in coming up with, let's say, alternatives, new ways of thinking, and especially from the environmental perspective. But it is quite often what the citizens want, the consumers cannot afford. And this is something that we need to keep in mind when we look at the market realities, because we are increasingly part of the international community when it comes to trade. Like seed sector actually is one of the front runners in terms of being internationally linked all across borders. What happens inside the EU borders cannot remain only in the EU. I would love to say that let's close the borders and let's say develop our own environment and our reality here. This is no longer realistic. And I would like to draw the attention to the ongoing discussion on let's say for instance livestock, or how should we eat differently. Most of these alternatives that have been presented to the marketplace, especially like replacement of meat typically, is a cocktail of chemical substances and highly industrialized process, where I wouldn't eat it as a replacement of meat for the fact that it is not a natural product. I have no problem with the safety of the product, and it may be kind of like acceptable. But if people say that GMO by definition is unacceptable because it interferes into the system and it is too artificial, how on earth are we going to justify, for instance, some of these replacements? Take a look into the product declaration and you would see the difference with the natural products that we have in the marketplace. So we are not very consistent in terms of consumer approach. But let's talk about what we need to do. And of course, we are very much interested in these technologies, especially gene editing, for the fact that it actually gives us some alternatives. It actually could potentially replace some of the questionable technologies that we have employed in agriculture. They are not necessarily unsafe, but if the citizens say that they are no longer acceptable, we have to take a look into the alternatives. And in this respect, we put a lot of faith into the gene editing, genome editing in general. And if we look at historically what has happened over the past 150 years, I think we have to accept the fact that about 70% of the performance improvement in our productivity actually originates from better genetic material of both plants and livestock. we actually produce food with less environmental and, let's say, generally speaking, environmental footprint. And this is a general trend and general rule for all economic sectors. We have to improve our productivity. And this is something that sometimes I miss in the EU statements. I would like to conclude by pointing out that while we talk about these technologies, we need to accept the fact that farmers and agri-food chain is there to produce food and ensure food security. Secondly, we have to do that in a competitive manner, internationally increasingly. And then finally, why I'm here is that we defend the interest of farmers' economic, let's say, prosperity, and it is finally agricultural income that matters. Thank you.
Thank you. There are so many points that are being raised by each of you that this discussion could go on for 2 hours. So we have a scientist with us, and I think, Dirk, how do you want to react from what you heard? There are so many uncertainties, so many question marks, especially on the consumer side. So do you want, well, that's a very tough challenge. You have, let's say, 2 minutes to explain what are the options on the table to reconcile the divergent opinions around the use of genetic engineering. How do you want to do that?
Thank you very, very much, Marilena, for this kind introduction. 2 minutes is very, very short for such an important issue. I would also like to thank the Leopoldina and the DFG for this very interesting meeting and to give plant scientists also a forum here. Of course, all what we eat, all what we produce for food is actually man-made. And over the centuries, actually, and of course, certainly in the last decades, science and plant scientists have been greatly contributed to the success of this human activity. And so, and currently, actually, by a worldwide effort of plant scientists all over the world during the last 4 decades, in particularly with the discovery of DNA and so on, we have now actually a very good understanding of many genes and many processes which contribute to beneficial traits of crops, being disease resistant, food quality, efficiency by which plants using nitrogen, phosphor, yield, and so on. But using this information in classical breeding processes is a really slow process, and it takes often many years actually to introduce the desired trait in the food that we would like to consume. And I think with the current climate crisis and with the sustainability crisis, we don't have that time anymore. So in view of climate change and sustainability, we need to enhance the precision and the speed by which we can develop new drought-resilient crops, disease-resistant crops, crops with reduced environmental footprint. And the question was asked, actually these examples are already there. Actually, they're already currently in a number of places actually commercialized. And this is really completely in agreement with the Green Deal and the farm to fork strategy, in fact, which states that we have to develop innovative ways to reduce the dependency on pesticide fertilizers and so on. But at the same time to provide society with sufficient, nutritious, sustainable and affordable food. So we plant scientists all over the globe, I have to say, unisono state that genome editing is an amazing breeding technology, achieving essentially the same as what we can do with classical breeding, but only faster, much more cost effective, and with a much greater precision. So in many of the application of precision breeding, no foreign genetic information remains in the crop. And I can tell you this consensus is also shared in Europe. We have, for example, an organization called EU-SAGE, which stands for European Sustainable Agriculture through Genome Editing, which is representing 132 European plant science centers across almost all European countries, with the exception, I think, of Luxembourg and Malta, where not too much plant science is actually happening. And we strongly argue that genome editing can really make a great contribution to the development of a productive, healthy, variety-rich and eco-friendly agriculture. And such innovation-driven agriculture, I would say such modern agriculture, it can perfectly coexist with organic farming. But most importantly, it should not be banned from Europe, as we will miss out on very critical innovations that, and also we will be subject to trade restriction that will jeopardize European food security. Let me conclude with a final remark. So often the so-called precautionary principle is used like for new technology. We discussed this already. This principle should be proportional to the real risk and should not discriminate between those who can use genome editing and who cannot. Crops that will be subjected to target genome edited, which do not contain foreign DNA, do not present, in our view, any other health or environmental risk than plants obtained through classical breeding technology. The features of the plant, rather than technique used to generate it, should determine its regulatory status. And we plant scientists also would like to call up on a kind of reverse precautionary principle and ask an infected society what will happen to European agriculture if breeders and scientists cannot use genome editing anymore while the rest of the world, which is actually the case, is embracing it. In such case, we might suffer more and more problems with drought, disease, low productivity, that necessitated the import of crops from other parts of the world. Is this the Europe that we want? It's time to call on all of us and from all kinds of opinions, really to join forces and really to use science and innovation to make agriculture and food production more sustainable in a world facing problems with population, climate change, and environmental degradation. And to end with a quote to a famous person, listen to the scientist. Thank you.
Okay. So, I'll ask the first question, okay, to all of you, and then Lucien, if you want, I'll come to you just in a second. If you want to ask a few questions or to read out a couple of questions from the audience, but just to get the discussion going, we've heard that there's plenty going on from a research and innovation point of view. That's the excellent research we have in Europe is just as good in that novel breeding techniques area than in other areas. But I also hear that there's a very high level of caution on the policy making sides and also on the Green Party in the Parliament. So I want to ask, well, these novel breeding techniques are flourishing everywhere in the world. So don't you think that Europe also has a responsibility to regulate the use of these novel techniques and GMOs, as it successfully did with data protection or chemical product with REACH, or as it's ambitioning to do with artificial intelligence? Isn't it time to regulate to secure a proper use of these novel techniques?
May I quickly reply to this? I mean, yes, of course we will, but I'm not so sure whether we will be the front runner of this. I mean, it doesn't have to be the green group. So there are others who are regularly much more in favor of, let's say, this innovative genome editing breedings, and my problem is I'm the minority in this group, and I share all what was being said before. So that's not a big deal. But I do consider that the majority of the group has a different opinion, and this is widely shared also by the Greens in, I think, mainly all parties in all member states. And as I said, it's not just the green consumer, it is, I guess, the society. So I think what would help is really explaining what you're doing it for, and also maybe what my team has mentioned in the morning, taking some of the experience you have done in Asia and Africa, where you obviously have empirical data. Where is the health of the farmers have improved with the application of those sorts? Where is really a reduction of pesticides, insecticides, herbicides, and so on, and really show to the broader audience here in Germany, really try to convince the people by the facts, I would say, and bring the researchers from those countries to Germany, let them explain why, for their purposes, it makes more sense than to applicate those and to use those breedings and genome editing sort. I mean, really try to explain why you want this, why it is important, why this progress is necessary for Europe, but also for the global situation in terms of nutrition. This would be my advice, because I see always we are trying to convince the least, let's say, affiliated ones. But let's start with a broader audience. Start in the schools. Start wherever you want. But don't tell always the Greens they have to be the front runner for this project. I mean, as I said, I'm more sympathizing with this, with the whole approach than anybody else. But nevertheless, I see there's a big reluctance, and not just in the Green Party, but in the society as such.
Wolfgang, you seem to agree. Do you have any advice in terms of improving science communications?
I entirely agree, because I firstly agree with Dirk. Listen to scientists. That's crucially important, but it's not enough, because you have to convince the society, and politicians, they listen to scientists, but they have votes. They need majorities. So you need the society to convince. And I think what Viola has indicated and you have referred to is exactly what one needs. Examples that these techniques are able to address our sustainability challenges. You use less pesticide, you do this. But I think another element, which I find personally very true and very important, and I'm agnostic on it. Dirk, you said there are hundreds and thousands of plant scientists. That is very good, but is it holistic? Have you checked with other people? What is the consequences on biodiversity? I have no clue what it is, but are these elements covered? We need holistic approaches. And I think that's also very important to convince people. I mean, it's also about the scale of changes that might have impact in many other areas. Are we really sure that these things are well assessed? So I think, again, for the reasons that Becca has set out, we are, agriculture is certainly very favorable to take up these innovative techniques. But if you want to have a regulatory framework or politicians to go in that direction, you need to have these kind of assurances.
Petra.
I completely agree that we need to have good examples, and that we also need to show that we can deliver. I completely agree with this. But what I see is we are in a difficult situation. What we can show is plant breeding has delivered in the past to help agriculture to be more sustainable. I mean, we shouldn't ignore that plant breeding has always already produced varieties which are more resistant to pests and diseases, which allow less pesticide and fertilizer use. So that we have done in the past already, and this is proven. It's a track record of success. But we also need to see that technology is going ahead, so we can be more efficient in that. And what we are doing with these new techniques is exactly, we follow the same, let's say, goals, breeding goals, which we had in the past: be more pest resistance, etc., more yield with less resource input, but with new technology. So it's nothing which is completely changing, let's say, revolutionizing plant breeding in view of its goals, but it's an additional tool in the toolbox of the breeder, which makes him or her more able to reach those goals. And I think we have this track record of success. We don't have it for those new technologies here in Europe yet, but we are in a bit difficult situation. As long as they are regulated as GMO, we won't have them on the market. We heard it earlier, there was no GM approval for cultivation since the end of the 90s. So we wouldn't be able to deliver as long as those products are regulated as GMO. Of course, people in other parts of the world might be able to deliver and also show the success, but I can already foresee the counter arguments. Well, that might work for Africa, but that wouldn't work for Europe. Show that it works for Europe. And for this, we are in a very difficult situation at the moment.
Okay, Sabine, you want to come in very short, because I'm told that there are many questions in the
Yes, of course. No, I mean, I think we have to be very clear. There is regulation, and Petra just said it. They are regulated, new breeding techniques and their products are regulated under the GMO framework. So my question is really to the industry, to scientists, what level of different regulation do you want to see? Do you want to see total deregulation? do you accept that the potential impact of any product, any outcome is assessed for safety, for health, for environment, for several aspects, maybe also for its contribution to the sustainability agenda? I mean, I'm trying to understand the argument because there is regulation, there is a way to the European market. Again, it is not an easy way. On the one hand, because of the scientific evidence, maybe, but also due to the political discussion around every authorization. So, I mean, I think we have to differentiate a little bit between the one scenario that says new breeding techniques are banned to the EU market. Not true, I don't agree. And we want something else, more maybe adjusted to the risk. But where is the landing zone, and how do you, the demandeurs, ensure that the societal discussion is following? Strangely enough, the societal discussion has followed when we talk about the use of the techniques for medicines. For the development of medicines. So very clearly, the citizens can differentiate where there's a clear benefit for them in their health and something which so far they have conceived as, more pesticides, more industrial agriculture, more concentration, more of things that deep down they don't want. So my question is, what are you really looking for? What would help? Thank you.
Dirk, you can answer to Sabine, but then I really have to turn to Leshen for a question from the audience. So go ahead.
Yeah, just from a scientist point of view, we find it very difficult to understand why there would be a different legislation for something that you can obtain by breeding and something by genome editing. It's just a method which is different. And that's very hard, but it makes a huge difference. For example, if you now want to go with the genome editing to variety in a field trial, which is absolutely essential, if you want to really bring something back to society, it's virtually impossible. In some countries, there's really legislation. It's very good. It's really classical GMO legislation. But the problem, is when it's so difficult, so many rules attached to it, you can actually not do almost anything. And in some countries, I mean, Germany, France, and so on, field trials have been destroyed. So it really blocks any innovation in that field. And of course, we as a society, we should think whether we should allow for certain application. Maybe you can question whether you would allow for herbicide resistance and so on. I mean, that's quite obvious, but that's different from allowing at least the innovation to progress to value for society.
Okay, Leshen, you go ahead. Do you want to pick two questions from the audience?
Thank you very much. Lots of controversies on the chat, as expected. Marilyn, if you allow, I would pick two personal questions, because I think they summarize well the discussion. The first one is this actually not something of driven by all this discussion is not driven by demonstrating a social group identity, and other put it like affirming a lifestyle, and somebody putting, I'm from Eastern Europe. For us, the question is, how much can we afford? So this would be the first question to everyone. Should I put the second one or wait for the answers?
No, go ahead. Put the second one now.
Second one is very interesting. It came from somebody who says, I'm a farmer myself. I have a mid-sized farm in a European country, whichever this is, and says, I'm threatened by lots of dependencies, so much that I cannot do my real job of being a farmer. I'm dependent on plant breeders, I'm dependent on consumers, on politics, on young people, on television, on everything. Why cannot turn to what we call a healthy agriculture? I don't really understand what this is. There was another question about thinking out of the box, like the farmer said. He had a long question. Why can't we think out of the box, for example, include genome edited plants for organic agriculture? So genome editing for organic agriculture, or ecological intensification, or try to get back from the way agriculture is being done right now, cash crops, intensive agriculture, rights of animals not being respected, and all those things. So 2 personal statements where I try to sum up the really controversial discussion, and I give it back to you, Marilyn.
Becca, I think the second question is for you, isn't it? You just need to.
Well, I actually appreciate the question, because this is actually an answer itself. Like if we put these barriers in place in our minds, we will never get the desired outcome. In fact, for instance, in organic, I met my organic farmer members and amongst our member organizations, and we always have the same discussion. They are really aiming at better improved production method for themselves in organic. So it's the same productivity increase that they aim at in organic. But the reality is that they don't have the toolbox like any conventional farmer has for instance, with chemical substances. And I completely agree with the farmer asking the question that we are dependent, and we are going to be dependent in future also on our regulators. But then the point here is that how do we ensure that in the best case, like organic farmers can actually develop their own production in the same manner that everybody else, because they will be in a very tough competition with this requirement for 25% of the land use. If we have 25% of the land use in organic, we will have a different kind of organic sector. It's not what we work for or want, but imagine the competitiveness of the organic sector that has to be enhanced in order to exceed that 25%. It's going to be a different sector what we know now. And my heart goes out to the organic farmers. How can they do that in their personal livelihoods and make it economically viable?
So are you saying that organic agriculture and gene editing can actually work together?
If you simplify that like that, the organic producers have to improve also the same genetic material like everybody else. And I think Dirk made a point that it's about time. The same time scale is imposed on organic farmers, the same adaptation to the environmental phenomena that they see, for instance, in prevalence of disease and pest, is exactly the same thing. And the bigger the market share for the organic, the bigger the challenges from the kind of conventional side that they would have. They face exactly the same phenomena. And in this respect, they need to be equipped like exactly the same thing, same way that everybody else. Look at the famous copper sulfate example. Why is it so sensitive for European agriculture? Because it's one of the last remaining tools to combat fungi. And we don't have a tool for the organic farmers to produce, for instance, in certain regions, wine. And if we lose these alternatives, that means effectively to those organic wine producers that they have to scale back or even stop producing their product. And this is not in the interest of society, and definitely not the interest of the farmers, the organic farmers that have made a huge investment into their production. So the same challenges are going to be there. They are not going to live in the bubble.
Understood. So that's probably one of the cliches that just killed in a second. Thank you for that. Who else wants to come in, either on this second question or on the lifestyle question? Anyone?
The lifestyle question was actually addressed to Viola, but everybody can answer. So I have another personal question from.
Viola, do you want to answer or no? You're muted. You just need to unmute yourself.
Oh, sorry, there was a different button. No. Well, if you have another question, because I have to leave pretty soon, that's a little bit my problem. So I'm a little bit under time pressure. If you have one more question where I could maybe together do a final statement, that would be great.
Okay, well, I'll ask one, okay, because we need a consensus here, well let's dream, but on how we can regulate. And so what should be the steps? We heard about the importance of science communications. We heard about the study at the Commission. So what are the steps, and what is a realistic timeline to modify, to reverse the current legislation?
You know, that's a $1 million question. And as I said, since the majority, at least in my group, in my party, is not really in favor of changing, and for some of us, where we try to open the process, I don't want to say we want to change everything, and there's no question about deregulation. It's just a question of what many people have said today: coherence, consistency in the regulation, and also more evidence-based, let's say, regulation, where I'm very much in favor of. But nevertheless, I respect majorities, and the majority is not there, not even in the parliament. So I'm very much looking forward to this study, which will be published at the end of April. I hope this is a good starting point for new debates. I also would use maybe the store a little bit more for, let's say, some side studies for off targets, for different disputable questions, where we could also already on the European level work on different issues. And then, yes, try to use the Horizon program for missions, for reach out, for trying to get the scientific-based community who is here now and who is very much committed, really try to prove and to show what you can do and why it is not just a commercialized high industry agriculture behind you, but really what you have said and explained before. Why could it be one milestone also for more sustainable, more for organic, and so on? So I don't want to convince anybody, but I would like to show, let's say, the portfolio of opportunities to people, and then they might decide. The question of labeling is still, of course, not solved, because it will be very difficult, but people would like to have a possibility to get labeled and declarations. So this needs to be solved, and I'm ready to debate on this, but I know there are many, many people who wouldn't like to have any kind of changes, and I do respect that, of course.
One final question for everyone here, and then we will wrap up. But in his first day in the office, the UK Prime Minister Boris Johnson said he promised to liberate UK bioscience from EU rules on genetically modified crops. So if and when the UK leaves the EU, pretty soon, it seems. So in parallel, some EU member states, like Czech Republic, but also Germany, if I'm not wrong, have shown some openness to adopting these new breeding techniques. So there is a momentum here. And from what you said, Viola, there could be an engaged debate also in the Parliament. But so how do we make sure? I mean, if the UK, that is right at the door of the EU, start doing its own thing, shouldn't we just? What can we?
UK is almost far away, more far away than anything else right now, so I wouldn't count on them. But of course, there will be a competitive situation in terms of research and innovation, for sure. I don't know whether I would like to see this. As many have laid out, it would be better to keep our researchers in the European Union, for sure. And we have to see how we're going to deal with this new competition on the island. But what can I comment on this? Yeah, let's see what they finally deliver and how this will be regulated or non-regulated. But so far, it's just an announcement, and Boris Johnson is great at announcing politics.
Yes, indeed. Okay, that was a bit provocative. Final comment from anyone? Sabine.
Yeah, I mean, I think everybody agrees that, a debate is needed, a fresh debate is needed, because we have, so to say, new tools. We understand better through the help of scientists, what can be achieved with these tools, how these could be used in a more democratic way. The Commission has, as I referred to, launched the Farm to Fork strategy. I mean, Commissioner Kyriakides is responsible for health and food safety. She has been, carrying that work forward in the Commission. And what this other aspect of sustainability food sustainability, you know, with the dimensions of economic sustainability, health, and environmental sustainability. What these offer is for us in Europe to discuss on the way forward, you know, what type of innovation we would like to welcome to Europe. You know, in this work, I mean, safety, no doubt. I mean, I don't think anyone is in any way opposed to safety for health and the environment, and some sort of assessment that new products that we are seeing, be it through NGTs or other tools which also exist, that this is fundamental to confirm safety. But I think the discussion out there and the societal concern is also around other aspects that I would summarize under the sustainability criteria. And what makes me optimistic is that in going forward on implementing the Farm to Fork strategy, in defining a legislative framework for sustainable food systems, so in defining what is sustainability for us in Europe, what is important to us, the environment, the social rights of workers, and so on and so forth. We can also more and more frame, you know, what type of innovation in the food area, for example, we would like to see in Europe. And if that discussion is well argued, well founded, we have the good examples, like we have, for example, in the medicinal area, you know, the atmosphere and the quality of discussion might change. So this discussion is needed. Everyone has to contribute with what they can contribute with. The delivery of the study is an opening for that discussion, in particular as the Council requested. So member states at large are ready to open this discussion. And obviously time has to tell, you know, in which direction we are going, but we have not to be one-dimensional in this discussion. There are so many aspects that all need to be considered. Thank you.
Okay, thank you. Those are very wise words. So I think this is a good summary, and so we will wrap up here. It is there is plenty of space for a debate, and it's probably fair to say that now more than ever there is space for every voices to be heard. So scientists have a very important task here in terms of communicating, probably jointly with the industry, and farmers do also have their say, obviously. So with this, I'd like to thank very much our 6 speakers. Apologize, we ran a little bit over time, but that's because we started a bit later, and I thought it was important to have this debate. So we will now take a break. And the next panel will start at 2:30 CET, so in about 20 minutes, 18 minutes. So please come back. The next panel will look at socioeconomic and environmental concerns of GMOs. So no, the debate is not over for today. Thanks again, and yeah, we wish you the best. Bye-bye.
Bye, many thanks.
Bye.
Evelyn, bye. Colleagues,
Bye-bye.
bye.
everyone. It's my great pleasure to welcome you to this third session of our conference on genome editing in Europe, new agenda or new disputes. This session is entitled Socio-economic and Environmental Concerns of GMOs. My name is Catherine Kistner. I'm a program director with the German Science Foundation, DFG. I'm the host for this session. And DFG has been a co-organizer of this conference together with Leopoldina, with our German National Academy of Sciences. I've been looking forward to this session especially, and I'm very pleased to be able to introduce our two co-moderators of this session, Professor Gerald Haug, who is the president of our German National Academy of the Sciences, Leopoldina, and Professor Axel Brackhage, vice president of the DFG, and as a microbiologist, he is also the chairperson of DFG's Senate Commission on Genetic Research. Thank you both very much for agreeing to co-chair this session this afternoon. I really look forward to this exciting and important discussion that I hope we'll be having. Before I hand over, just one quick technical remark about how we want to handle questions that we hope will come in from the audience. Please use the questions and answers tool that Zoom offers. You will find this questions and answers feature on the control board in the lower part of your screen. You may send questions anytime during the presentations we are going to have, but please note that these questions will be answered only at the end after all presentations have been given. And of course, you may understand that it might be necessary to select if there are too many questions and time would be too short to answer all of them. And then there's another remark that I have to make, another announcement about a program change at rather short notice. Unfortunately, Professor Sabine Schlacke, who was to present on the precautionary principle, cannot be with us this afternoon for unforeseen and very unfortunate circumstances. Luckily, Professor Dehrer was able to come in at short notice, and he would be available to answer at least questions that might be related to the precautionary principle. With that, I'd like to hand over to Professor Haug now, just briefly as another word of introduction. Gerald Haug is a paleoclimatologist and a marine geologist, and he is a director at the Max Planck Institute for Chemistry in Mainz, and at the same time a professor of climate geochemistry at the ETH Zurich. Professor Haug, I'd like to hand over to you.
Thank you, Dr. Kistner. Distinguished colleagues, it's a pleasure to also co-welcome you to session 3. As you've heard, I'm a non-expert on the topic. I'm here clearly on a very steep learning curve, very interested in what you do. I look forward to the themes. The Sustainable Development Goals, of course, are at my heart as a paleoclimate person. And to see how they fare in the light of biotechnology is of great interest to me, as much as regulation and over-regulation scenarios at the GMOs. It's clearly a heated debate, as well as the biodiversity and food security aspects. I think there is a very interesting session, but without further ado, I should hand over to the experts here, and the expert moderator who will run you through that session is Axel Brackhage. The stage is yours. Thank you very much.
Okay, yeah, Gerald, thank you very much for these nice words. I just would like directly go into medias res, and we just go to the talks because this is why we are sitting here. And I would like the first speaker to ask the first speaker for his talk, who is Pablo Orozco from the Cornell Alliance for Science, and he's going to speak about biotechnology in light of the Sustainable Development Goals. Please, Pablo.
Yes, thank you. I'm just like to set up my presentation here, if that's okay with everyone. Great. So first of all, thank you for the invitation. It's a real pleasure to be here with such distinguished colleagues. I very much enjoyed the previous talks, and it's a great pleasure for me to present on socioeconomic concerns in light of the Sustainable Development Goals. Now, my presentation will be mostly through the voice of our fellows, the heart and blood of our program at the Alliance for Science. So I'd like to start with, even if it's repeating some of what my distinguished colleagues have said, I'd like to start with the facts. We will have more drought, we will have more environmental stress, and we'll have 1 billion or so more mouths to feed. But we can't use more water, we can't use more lands, and we can't use more inputs in general. So if we want dynamic and sustainable agricultural systems without more input, our ability to improve the basic characteristics of the organisms on which we rely on becomes very important. Now, that's why generally plant breeding has a history of innovation, and also why biotechnology is a tool that holds so much promise and can be considered within the UN's 2030 Agenda for Sustainable Development, which we've seen in different documents. Now, the socioeconomic and environmental impacts of biotech have been recorded through different studies, and we can say that they clearly fit into the SDGs context, mostly because they can help alleviate a social toll that is brought about by climate change and the lack of sustainable practices. Now, of course, not all of these applications will comply with this, but there are some that definitely fit the bill. Now, a clear example of that is BT brinjal in Bangladesh. And when we talk about BT brinjal, I'd like to go through the voice of our fellows who are the boots on the ground for these technologies. And they're the ones that are allowed to talk to farmers like Milon Mia, who has, thanks to this BT crop, cut his pesticide use by 90% and clearly earns extra income. Now that's one particular story, but if we take a step back and we look at the facts, we can see how this BT brinjal, this GM crop, has shown to help reduce poverty by allowing farmers to save on pesticide costs, increase their net returns sixfold and their gross revenue. And it has direct impact on the reduction of the use of pesticides. And so there is studies that really demonstrate how this technology can be used in light of the Sustainable Development Goals. And that's why our fellow, like, for example, Arif Hossein, not only is an advocate and a clear believer in this technology, but also went the further mile and created its own organization, a local organization that works to promote access to agricultural innovation, precisely because he has seen the benefits of this technology and how it can really be part of a poverty reducing strategy. Now, if we take it one step further, and then we talk about gene editing, and we can see how this technology has the potential to shape how we use agricultural biotechnologies, not on its own, but as part of other conventional breeding programs and in combination with other efforts. I think everybody here can agree that when we're talking about reaching sustainability, we don't really believe in crowding out other options, but I would think that everybody agrees that coexistence should be possible to reach these development goals, which really transcend policy or science, because these SDGs are really about the humans we want to help. Now, if we think about that and we think about the poverty reduction aspect of these new technologies, we see how we can use technologies to create crops who have traits that can really actually benefit local communities, local farmers in a myriad of ways, from drought tolerance to increased grain that can ultimately result in economic benefits for the farmers. Now, if we keep on going down the SDGs, we can see how one that comes to mind quickly is golden rice. And that's because biofortification is really at the heart of what other UN agencies like FAO have thought about when we think about reducing hidden hunger. Now, this can come in different forms and different shapes, and the traits that are being worked on currently go across the board. We can talk about biofortified bananas, we can talk about improved rice, we can talk about virus-resistant banana or healthier rice. But I think I have had the pleasure to meet researchers whose thought process goes, we want local varieties to keep what makes them local, but also add value by improve their quality. Now, again, as I mentioned initially, my talk I really want to focus on our fellows' voices, who, for example, Modesta from Nigeria, who is working on improving flavor content in tomato, Navneet Kaur from India, who is working on enriching B-carotene in bananas, and Murenga, who is working with the Wema Maize project in Kenya. Now, these fellows don't just work in the lab, but they also are aware that they need to voice what they're doing and what they believe in different forums. Because innovative new biotechnologies is really a cross-cutting tool that can allow local, publicly funded, low-risk research solutions. And they can be used in a myriad of ways to address the challenges that we can see regularly in climate change. And now if we pause for a second and look at how we could combat climate change with these new technologies, we talk about heat, drought, and salt-tolerant crops. And a couple of our fellows are working in different areas of the world that really show how different the approach can be. And this is a recent development in Chile. The Plant Abiotic Stress for Sustainable Agriculture is working on kiwi and tomato that is going to be drought resistant and salt tolerant. Now, knowing what we know about Chile, it's really looking to create sustainability within their agricultural system. And then if we switch the page or turn the page and we talk about WEMA and the different drought-resistant mazes that are being developed for an area in Africa, for example, Tanzania, Kenya, Zimbabwe, Uganda, and others, they're really talking about helping farmers face those direct consequences of climate change and reach sustainability. So that I wanted to bring that up because I think it really shows how this cross-cutting tool can be used in different contexts and different parts of the world. Again, one of our fellows, Nkechi Isaac, a science communicator who believes in how science can help constant development, really sheds a light on the fact that there are farmers that right now need these crops, and that if we can work together as a society to develop these crops in a safe and a responsible way, this technology can definitely benefit stories precisely like Selma, who is really facing the consequences of climate change. Following down the line of the SDGs, we can see how from our fellows, initiatives have begun, much like Farming Future Bangladesh in Bangladesh, in the same way, Women Who Farm Africa, who is 3 amazing fellows who begun this organization and really demonstrate the power of partnering for these goals. Now, we are partnering with them to do stakeholder engagement, and not only that, but also capacity building specifically just on farming practices now, and they promote gender equality and really demonstrate the ethos of the Alliance for Science. In general, I think Clet Masiga from Uganda really said it best when he mentioned that every field is using scientific innovation to advance, and there should be no exception in plant breeding. I think in a post-pandemic world where we know that our food systems will be taxed, and we are definitely facing global food security problems, we need to use all the tools we have to be able to overcome these challenges. So to end with my talk, I really wanted to narrow in on the potential implications of the social and economic concerns and how they could be included into the decision-making process. Because when you're thinking about establishing biosafety frameworks that will allow different products to go from lab to commercialization, and you want to integrate sustainability and allow innovation to go forward, we really have to balance information. We really need to understand, we really need to take into account the social and economic benefits of, again, not every application, but there is definitely distinct data and distinct information that shows that this technology can really help us achieve the sustainable development goals. So when we think about the social and economic concerns, as it's been mentioned before in different panels, we need to allow innovation in a safe and responsible manner. So we need to really think, what are the issues relevant to the technology decision-making process? Workable systems with clear rules and standards will facilitate the different public sector developers to really drive towards sustainability, and all different types of developers. So an over-complex regulatory system can mean high compliance costs, and what we would not like to see is that potentially regulatory delays could reduce the number of technologies that public sector institutions can present to the world, as we've seen in BT Brinjal. And we wouldn't want a repeat of some of the few products that are out there that have been put forth by public sector, like golden rice, having 15 years to get to help the end user is a little too long. So the objective of my presentations was to really allow a platform to voice our fellows who are all over the world, who really understand the technology and how it can allow local solutions for local problems brought on by the big picture problem, which is climate change, lack of sustainable practices, and poverty in general. For that, I think I'm on time, so I will stop there and thank everyone again for allowing me the time for this presentation.
Okay, Pablo, thank you very much for your talk. We can move on, and I would ask Dr. Monika Messmer from the Swiss FIBL Research Institute of Organic Agriculture to speak about the impact of future GMO regulation scenarios on the organic sector. Frau Messmer, thanks a lot for coming. We are looking forward to your talk. Thanks.
Screen?
Yes, we can see it, but I think you have to switch it on. Yes, I think. Yeah.
Okay, now it's better?
Yes, now it's perfect. Thank you very much.
Okay, then thank you very much for the invitation, and I'm quite glad to be here in this very interesting session. And I have to apologize that I can't join the morning, but I also got informed on a short notice. And I'm glad to be now in the session 3. And I would like to show you also what is the impact of future GMO regulations on the organic sector. And I just want to start with the organic sector in Europe. I also want to show you that we have 13.8 million hectares of organic farmland. That is about 7.7% of the total farm area that we have. And we have quite a big number of farmers and processors that are working in the field. And the whole value or turnover of the retail of the organic sector is 37.4 billion euros. And there's also an annual growth of plus 7.6 or 7.7%. And this is actually something that is going on since several years. And I think for the food market, the organic market is probably one of the most strongest one that is growing. And also we are quite happy about the new EU Farm to Fork strategy that was published this May, that aims to increase the share of organic farmland to 25% within the next 10 years. I think that is a very ambitious goal, and we really think that plant breeding has to contribute to achieve this goal, and to make also the organic farming not only very sustainable and environmental friendly, but also highly productive. Just to come back to the principles of organic agriculture, the principles are based on 4 issues: on the principle of health, the principle of ecology, the principle of fairness, and also the principle of care. That's also called the precautionist principle. What is very specific about the organic sector, that it is value-based and process-oriented, and it is defined by the organic sector and was later taken over by the EU regulation. We have since several years quite intensive discussions and debates about the compatibility of breeding techniques with organic agriculture, and this had been discussed at different levels. And I just want to point this out because usually it causes a lot of misunderstanding and unfruitful debate if people talking on different levels and not going to understand the other side. So on one side there is the issue on risk, on the precautionist principle, the risk for human, animal, or plant health, but also soil fertility and environmental in general is very important. And here the organic sector is probably more on the very precautionist side before applying any new technology. But then moreover, there is this ethical issue, and that is not so much related to risk-benefit evaluations, but it's related to how far shall it be allowed to modify organisms directly at the DNA level. So it is an ethical value. Do we have the right to do that? Should we do that? Should human, whatever we are able to do with our science, apply this? And are we capable of really using the new tools in a good way? And then there's the other level that is more on the socioeconomic issues, that it's related to intellectual property rights. It concerns also farmer privilege. There's a strong concern about the market concentration of the seed companies worldwide, and also the dependency of the farmers on hybrid seed, so that they more and more lose there's independence on farm-safe seed. And on the other side, there's also the expectation and the trust of the organic consumers, what they expect from the organic food they're going to buy in the shops. In the European Union, organic agriculture is GMO-free by definition, and GMO is forbidden in the organic production and processing. That is already in the present regulation, and this has been confirmed in the new regulation that will take into force either January 2021 or might be delayed by 1 year due to COVID to January 2022. I'm just coming a bit back to the ethical issues that have been discussed, just to clarify you what are the major issues that have been discussed. And there was quite heavy debates about what is the smallest entity that needs to be respected, and how can the integrity of a plant be respected. And then it came down that the genome should be respected as indivisible entity, so that there should be no technical or physical interference below. So that means no intervention with isolated DNA, for example. And it went further to the discussion that actually the cell is the smallest functional unit. From one cell a whole plant can regenerate, and that therefore this functional unit should be indivisible or respected the integrity of this unit. And that would, for example, also prevent cell fusion, where you take isolated cells, where you remove the cell wall, where you destroy one of the nucleus and then fuse the different cells, for example, to make cytoplasmatic male sterility of cauliflower or broccoli, which is a common practice in vegetable breeding. What is also important is that the reproducibility of the species should be maintained. That means that the plant, even without humans, should not be modified in such a way that it cannot reproduce itself without humans. And there should also be no legal or technical barriers that restrict breeders' rights. For example, when you have hybrids, then you have the farmer cannot use that, or if you have, for example, a vegetable or cauliflower that is male sterile, then you cannot use it in your own breeding program. And of course, if you apply patents, then it's also restricted for breeders to use it in their own breeding program. The other issue that is discussed is about natural crossing barriers that should not be overcome. So that means that crossing barriers might be extended to a certain extent by bridge crosses, but not by bringing together species that cannot cross-fertilize in nature. And also quite debated is that we should promote open pollinated varieties as an alternative to F1 hybrids that are taking more and more over. Even now in the cereals that have been for many centuries been line breeding, that are now transferred to hybrid seed. And the reason is not only that the hybrid vigor is so much higher, but also for the reason that the farmer can't use farm-safe seed. And one of the very big issues that was discussed is that there should be transparency what kind of parental material is used, but also transparency in the breeding techniques that are used. There are several positions of the organic sector, how to comply with the new breeding techniques or the new genomic techniques, as they call it now. There has been quite early a position paper of ÖkoPB, that is the European Consortium of Plant Breeding. They made a position paper on organic plant breeding to define what we understand under organic plant breeding, and also to see what are the limits and which techniques comply and which do not comply. And this was also then further developed on the international level, on IFORM International, that is the organization of all the organic movements. And there was a position paper, New Breeding Techniques, submitted in 2017. It was it went through the consultation for the different members, and then the final approval was at the General Assembly in November 2017. And the main outcome of this position paper, or this booklet, it's more a booklet than a position paper, is that it shows clarity and transparency on the criteria that are used to determine which breeding techniques are compatible with organic farming, and and also it differentiates between what is allowed, or which cultivars are allowed for organic cultivation, and which cultivars are allowed, or which techniques are allowed to do organic plant breeding. And the whole exercise was that the sector doesn't have to develop each and every new technique on its own, but that are criteria defined, and based on the criteria, then it's quite easy to evaluate the different methods if they would be compatible or not compatible. There is also the European IFOAM Organics Europe made a position paper and had collected quite a lot of information on the new genomic techniques, which are not, in their view, are not compatible with the organic farming and should also be declared as GMO according to the EU regulation and be labeled accordingly. And there is also a German paper, since we are having this German organizations that are doing this webinar. It's from the Bundesverband Ökologische Lebensmittelwirtschaft. These are the association of the organic food industry. They put a position paper also in 2018 that they also say that technical intervention below the cell level should not be compatible with the organic agriculture, and that also natural fertility need to be remained. I think what is common to all these documents and all this discussion in the organic sector is that transparency and traceability is a very high value for the sector, and only this allows the freedom of choice for the organic farmers and the organic consumers. What is now the impact of the present scenario of the regulation that is called Scenario 1? According to the European Court of Justice decision in July 2018, genome editing is regulated under the GMO regulation. Therefore, the products must be declared and they're not permitted in the organic sector. In addition, there are about 17 European countries that ban GMO cultivation, that make use of the so-called opt-out order. That means that they ban GMO even if they would be allowed in Europe. And the consequences from gene editing and products that are entering the market, and even if they're declared as GMO, is that the organic sector and especially the organic value chain needs to follow all measures to keep the organic sector free of GMO and to avoid any contamination from seed to the blade. So that takes a lot of effort. It is a very high cost for GMO testing and organic certification, and to get the GMOs free certificate from different partners all along the value chain. There is always a risk of declassification due to unintended contamination. And the most difficult is to maintain purity of organic seed, as for example, GMO is grown at the moment as BT maize in Spain. The organic sector have given up the maize growing in Spain, as it was impossible to have GMO-free maize in Spain. So until now, all these costs are paid by the organic sector and not by the GMO industry, and also not by those who are using the GMO. If we come now to the future GMO regulation and to scenario 2, that would mean, for example, that genome editing is no longer regulated as GMO. So it is expected that then the technique will be applied in many breeding programs in Europe, and also products derived from genome editing will be produced in Europe and also be imported. However, that it's not called GMO will not mean that the organic sector will embrace these techniques, as they already stated that the novel genomic techniques that involve genetic engineering in their process will not be compatible to the organic sector. Therefore, it's for the organic sector also not very relevant if you see big changes in the final product, as for the organic sector in general, the process is a very important part, and even the certification of an organic apple is not based because you see a big difference on the product, but because you can certify that the whole process has been done in different ways, that you have started with different plant material, that you started with different farming systems, that you have taken different care of the landscape. So the whole system of agriculture is very different. And for this, I think it's very important, as I said before, that we have full transparency. And this is actually very important, that the organic sector can maintain its integrity. For this, we need labeling and traceability all along the value chain. We also need detection methods to minimize unintended contamination and also fraud. And we also expect that there will be a very high risk of contamination and that this risk will increase with the increased commercialization of genome editing derived products. And this will also increase the costs for separate value chains and for certification. That also means that there will be in the already now, but even in the midterm, there will be a separation in organic or new genomic tool-free breeding processes compared to conventional breeding programs that are applying these methods. That will also result that organic farmers will have a smaller choice of cultivars, and also the organic breeders will have less crossing parents available, and this will hamper to participate on the general breeding progress as they do at the moment. When we come to scenario 3, that would be the one that genome editing is no longer regulated and it is not declared. And in this case, it will be actually impossible to keep new genomic technologies out of the organic sector. That would mean that the organic sector will lose its credibility and trust. Farmers and consumers will no longer be able to decide on their free will with what kind of food or what kind of seed they want to choose. And it might also cause a very strong decline of the organic sector in Europe, which will have a very negative impact on economy, environment, and the society, as we still see, and it also has been acknowledged by the European Commission, that organic agriculture is kind of a forerunner of sustainable agriculture, as it develops systems that are not exploiting the system, but working with the system and working with nature in order to make sure that we have also in 10 and 20 years or in 30 years fertile soil with a good fertility where we can grow our plants. So in conclusion, for us, the new GMO or new genomic technology regulation, however it will be called, it must request full transparency and traceability of GMO and new genomic techniques to safeguard the integrity of the organic sector and the freedom of choice for citizens. The legal framework must ensure that the organic sector can remain GMO and NT-free. And this is important because otherwise we will not be able to develop 25% of organic farmland in 10 years. The legal framework should also protect the income and the livelihood of organic farmers and processors in such a way that the contamination of non-GM or NGT material should be prevented by the GMO producer in the first place, and that detection costs to identify fraud or unintended contamination should be in line with the polluter pays principle and not those that really don't want to use the technique. That also means for the breeding and the organic breeding that genetic resources need to be protected, preserved and maintained to stay GMO and NTG free, to allow this further establishment and flourishing of the organic sector. Also cultivars and animal breeds acceptable for organic sector need to be identified, as that it will also strongly restrict the availability. And I think, and quite important is also that greater public resources are needed for research and development of breeding innovations that are acceptable for the organic sector. There have been now 3 European projects working on boosting organic seed and plant breeding in Europe that are working on this issue, but of course they have a limited time frame, and seeing the big demand that we have to develop, it is quite a lot of effort possible. And I just also want to stress at this point that organic plant breeding doesn't mean that we are not using innovations, but our innovations are based on breeding for diversity. We're breeding for mixed cropping systems. We're breeding for improved plant microbe, soil microbe interaction. We're trying to develop new cultivar types. We're trying to breed for agroforestry systems, so we try to use organic plant breeding not only to fix one trait or one problem that we have, but we really want to use plant breeding to develop more sustainable farming systems that allow us to continue our healthy food production. And yeah, the last demand that we would have is that intellectual property rights need to be fair to all, and it should be prevented that cultivars or plant species are protected by patent, which do not allow the breeders to use it for further breeding. And with this, I would like to thank your attention, and thanks.
Yeah, okay. Dr. Messmer, thank you very much for your presentation. And as we said before, unfortunately, Professor Schlacke isn't able to attend at this time. And I would like to ask instead Professor Dedra from Passau to have a couple of comments, because I mean, the next topic was more on the precautionary principles and the comparison between the European Union and the Anglo-American approach. And I don't know, Professor Dedra, please, what you would like to state now.
Thank you very much, Professor Brackhage. Yes, I was asked to step in because my colleague Sabine Schlacke obviously is unfortunately prevented from holding this talk. Now, I would like to make only 3 points. So please, I have to apologize, I didn't prepare any slides, so I will speak without slides, without PowerPoint presentation. Let me make simply 3 points about the precautionary principle. The first point is, there is a serious misconception about the applicability of the precautionary principle. It is often held that the precautionary principle is not really associated or is not related to science. What is true is that the precautionary principle applies in cases of scientific uncertainty. That is true. But that doesn't mean that the precautionary principle is not related to science. To the contrary, the precautionary principle applies only if scientists see at least the possibility of risk. And this is fully in line with the ECJ jurisprudence, the jurisprudence of the European Court of Justice. And please let me simply quote from its jurisprudence. Quote, a correct application of the precautionary principle presupposes first, identification of the potentially negative consequences for health or the environment. And second, more importantly, a comprehensive assessment of the risk to health based on the most reliable scientific data available and the most recent results of international research. So clearly, the application of the precautionary principle, the invocation of the precautionary principle is related to science. So any precautionary measures must not be based on purely speculative or hypothetical considerations. My second point is also addressing a misconception of the precautionary principle. And this is that people think that the precautionary principle allows for or even calls for the most stringent, restrictive or prohibitive regulation. But again, to the contrary, this is a misconception. To the contrary, the European Commission already 20 years ago in 2000 issued a communication on the precautionary principle and its application. And in that communication of 2000, the European Commission mentioned 5 principles which should guide the application of the precautionary principle. And these principles are the principle of proportionality, the principle of non-discrimination, the principle of consistency, the principle to balance benefits and costs of action as well as inaction, and 5th, the principle to review precautionary measures in light of scientific developments. And that means that any precautionary regulatory framework needs to be dynamic by nature. That means it needs to be dynamic, needs to be able to adapt to the progress in science and technology, needs to be able to take into account developments in science and technology. And that leads me to my third and last point. The European legislator, but also including the national legislators, did not comply with the precautionary principle, not because the GMO regulation was not strict enough, but rather because the legislator did not take into account scientific knowledge or the progress in scientific knowledge and scientific experience. Because what we see and what we know is we used genetic engineering for 30 years, and we also did a lot of safety research using taxpayers' money. And after 30 years, no results actually, no results were achieved which revealed risks associated with the technique of genetic engineering. Another point, and this is the very last point, is that that also the principle of consistency is not be complied with. Why is that so? The principle of consistency means that we should not apply different levels of protection for health and environment to same or similar situations. So in cases of same and similar situations, we should apply the same level of protection. But what we do if we subject genome edited organisms to the current GMO framework, we apply a high level of protection to genome edited organisms, but we apply a low level of protection to organisms resulting from the additional breeding techniques, even though both organisms may possess the very same modification. And for this reason, it doesn't seem in compliance with the precautionary principle if we subject all genome edited organisms to the GMO framework. So this was my short statement. Thank you very much.
Professor Dederer, thank you very much for your statement and that you stepped in, and we have you available then for the questions later on. So we will continue to our last speaker on this session, and this will be Professor Alexandra Maria Klein from the University of Freiburg. And she's going to speak about the conservation of biodiversity in agricultural landscapes without compromising food security. Please.
Yeah, thank you. Do you hear me?
Yes, and we see perfectly your slides.
Great. So I will just continue. I'm going to talk more about biodiversity in agriculture, in agriculture landscapes and how to compromise this with food security. I might say a couple of things that were already said this morning, but I will give some results, or let's say some scientific evidence for it. So we know that biodiversity, or let's say just insects, are in decline, and we don't know it since last year. We even know it longer. I don't know if you see the publication. Do you see, because I can't see it here on my screen, do you see from where the publication is? I hope you see it. It's from 2014.
Unfortunately, I cannot see it.
Okay.
Just mention it. Thanks.
Okay. I mentioned because I have for all of my slides the backup of the papers, but in the end I have a summary of all papers. So everybody who's interested could just look at the summary. So you see already from in 2014, we had pretty good evidence for abundance of Lepidoptera here, of butterflies, that they are in decline. And coming to the EU level, because we will release from the Leopoldina a report in 2 weeks, and there we came up with these results, or you probably can't see it, but here from the 19th to 2016, we have a decline in the EU. It's from many EU member states. Almost all, we had a decline of butterflies for 30 years. And you see the up and downs. So, for example, the first 10 years, first you had a decline, and suddenly it goes back to the value we had 10 years before. This is why it's really difficult to see trends in insect abundance or diversity. We also see this for other species. Here it's an endangered bee species, and this population dynamic is from a protected area in southern Germany. So this means we have populations of, this is an endangered, a rare species, but also of common species, of very common species. And we have these, at least in Europe, this is from Germany, in protected areas and in non-protected areas. And this is also from our report. You can't see it, but I give all the evidence in the end of my presentation. I'm just coming to birds across the EU. Here it's a change in abundance of 167 bird species. And when you just look at the species that are depending on forest, you see a decline, but it's not really dramatic. But when you look at the species that are maintained or that are really relying on agricultural landscape, you see a drastic decline. And this is not just for birds. We see this and we know this. We have pretty good data in Germany also for insect. So populations of one common species are declining and are still in decline. So this is from the 19th to 2015, and we even have better data now. And they especially do it in agricultural landscapes. So now I'm coming back to something what Katja Becker said this morning. We cannot just go back to what we have pre-industrial, and I totally agree with her. But anyway, when you look at the causes of biodiversity decline, you see first, habitat lost, second, land use intensification. And I just make it simple and say land use intensification also includes insecticides. And this will come with our Leopoldina report. Of course, when we have these nice landscapes with lots of forest, we have many species, high diversity. And when you have a simple landscape, you have less diversity. What is also there, of course, many other causes, but these are the most important causes at the moment, according to our literature. But I just want to make the point, there is, of course, a publication bias in here. When we look in 5 years' time, I'm pretty sure climate change is coming first, because climate change is just going to start and we are just coming with the results. And then we have a real problem because climate change is facing food security and is probably have a real drastic impact on biodiversity. So here in this picture, you see already there's a big trade-off in conservation biodiversity or to conserve biodiversity, and on the same hand, conserve food security. But I would like to make this point even in a different context from my own research. So this is actually a figure that comes from an EU project that we finished a year ago. It's apple production, and we counted bees, we counted any predators or any beneficial insects and all the pests, and we also measured production, apple production in the end. This was in 84 apple orchards across the EU, and half of them was managed organically and half of them conventionally. And what you see, it's a pretty complicated graph, so I just want to make sure you understand the main messages. Organic management have, of course, or not of course, it has a benefit of all the natural enemies, of all the richness of beneficial attributes. But interestingly, not on bees. For bees, flowers, if you have a flower strip in there, was most important, more important than switching from integrated pest management to organic pest management. And if you have these beneficial insects, you have less damage, different kind of damage. I'm not going into the details. But anyway, these, I can't really point to it, but when you see these red things, these are negative correlations. And this means even when you have all these benefits for biodiversity and organic production, in the end, you still have a negative effect on food production. And I think we have to take this seriously. This is a specialty crop, it's an apple, so you will find different results in other crops. But anyway, we have to consider that just going organic will not prevent or will not increase biodiversity without compromising food security. But this was said before, I just want to show some results. So what are the actions? What can we do? And I'm just raising a couple of things. I can't go into the details, but of course we need to change the CAP. And this is what we bring in our report in real detail. We, in the report of the Leopoldina, we really go to the point that we have to transform society, less food waste, and so on. And we have to change the agriculture markets. We have to go to the law. We need to adapt some laws, and we need to make sure that the regulation works, because we see that in agriculture, not always the regulation really works. And we need innovative concepts, not only in IPM. I really think we also need it in organic agriculture. And this brings to the point, what is innovative? It could be artificial intelligence. We made this point in our report, because artificial intelligence can promote small-scale farming. For example, when you have robots, this is a big robot there. I didn't find a picture of the smaller ones, but the future will be much smaller ones, likely, and then you can promote small-scale farming. And of course, we also made the point that breeding is important. Breeding for diseases and climate risk. We know all this. And then coming to breeding, we have, of course, the advanced conventional breeding. And we can go for novel breeding with gene-edited GMOs. And here I'm just meaning CRISPR-Cas, as it's getting too complicated when I mention all of the gene-edited methods. This morning I asked this question, is there actually a table, or do we have good research showing the advantages and the disadvantages of all the different methods, of the methods in conventional breeding and the methods in gene-edited breeding? And the question was, we don't see any risk so far, and I'm always getting this question. I was searching for such a table, and I even started with such a table. There's actually no research. There's nothing really comprehensive available, just to make this point. So what we have to do, I think we should be open to gene-edited methods, or I call it novel breeding, because I think you need a new term for it anyway. You can't go with an old term in order to convince society. But risk assessment, of course, need to evaluate or need to ask the question how unintended changes at the genetic level impact the whole organisms. We have this kind of research, but we don't have really research showing in the risk assessment so far how is this interacting with the environment. And this brings me just to explain you what I mean with that. Novel organisms, of course, are just different genotypes. And for me, it's from the biological point of view, it's not a different. If it's a conventional breeding or a novel breeding, it's a different genotypes. And we know from many different research, also from my own research, we are also working with different genotypes and looking how the food webs are changing. And there is a huge effect on diversity, on food webs, on functions, also in adjacent ecosystems. So if you do any risk assessment, if you are doing new research, you have to consider this. Then, of course, gene-coded toxins do not only affect the target organisms, they affect also the non-target organisms. We know this from GT in mice, but also in any other GT crops, that they affect many different organisms. So going to a toxin that's just coming for a plant also need this different, this research angle coming from the ecological theories. And all these really need to be included in risk assessment. Just to sum this up. I need to sum it up. So I would say novel plant or even animal breeding can potentially contribute to biodiversity food production challenges. It looks like this, that it can be, but we need many more research to figure this out. And we need it from inter and transdisciplinary point of view. And just one point, these novel breeding should by no means be the main solution to secure future food production. We need these other concepts, and there was, you can't see it, but there's just a couple of new publications in Nature Sustainability, and they bring a couple of ideas up. And here are all the references because you couldn't see them. Thank you.
Yeah, thank you very much, Frau Klein. Thanks a lot for your presentation. And now we have time. Unfortunately, we are already basically over time, but I would suggest we have a lot of questions in our F&A, and I just would like maybe to select some questions that each of the presenters is involved. And we had quite some questions also addressing thank you very much. We had some questions addressing the talk from Monika Messmer. If I could ask you maybe to start, and I try to summarize them a bit. There's several from here, from Cecilia Gonzalez and also from Detlef Bartsch. And it's basically saying that the plant breeding principle also is human intervention. And why do organic movement seems to go back to the beginning of crop breeding centuries ago, when we can use more precise technology? And also related to this question was the question, why do you define DNA as an indivisible entity? You know, because also myself, I'm also a molecular biologist. I mean, DNA is changing all the time in all cells everywhere. Thank you very much, Frau Messmer. Maybe you can answer.
Yeah, I think the discussion, what is the smallest unit? Is it the cell or the DNA? That was actually, it came up with the cell, that this is really the smallest part that we can regenerate as a whole. So and there you have all the information, everything, it's included that the plant can reproduce itself. And why the organic sector is, we don't want to start from 50 or 100 years ago. We actually do innovations, but we see the innovations much more like it was presented in the other talk. And we also think that gene editing, without going into big risk and benefit discussions, but I think it's also overestimated, because even if with gene editing you can edit 10 or 100 genes, but the job of a plant breeder is to get in harmony 20,000 genes. So it is not only that you can fix some part, and I actually see some risk if we focus all scientists now focusing on one single technique, that we actually losing what we have learned about quantitative genetics, and that maybe in apple breeding people start stopping to make crosses, because then it might be much more easy and much faster commercialized if you then take one apple gala that is all grown all over, and then you put in something against fire blight, something about against scab, something against aphid, but still you have the same genotype. And the same is true that it's now discussed with the banana, where we have already in the 60s made the big mistake that we had all the same Gros Michel banana all over. Then it became susceptible to fusarium. Then there was a big disaster. Then we were looking for something others. Then now it's Cavendish, and we have not learned anything of history. We grow Cavendish all over the world, and now we say, okay, without CRISPR-Cas we can't save this anymore. But I think we need to balance a bit what the new techniques can be, and we have to be also maybe a bit more humble to see that the organism is a bit more than just the sum of the different genes then you can put together in like you think that they would react. Because in what has been shown, even also with all the GMO trials in the past, that the final product at the end reacts different because the gene expression might be different. There might be different feedback loops. So I think we don't know everything of the plant yet, and so for the organic sector, it was just a decision because it's a private sector. It is free to decide on its own. It also decided not to use soluble nitrogen fertilizer. That was decided, I don't know, 60 or 70 years ago. At that point in time, there was no scientific evidence that this would lead to salinity and soil erosion if you overdo it. So I think we see our role that by not using the techniques, that we're becoming much more inventive to explore other paths.
Thank you very much. Before I move on, I just would like to ask the speakers, but you can think about it. There is a question whether you would allow to share your transparencies with the audience, but you can think about it, and then we would, of course, I would not put pressure on you yet. Just think about it. At the end, we can do that. I would like to continue with a question which was now first, I think, to Professor Dederer. And one question from Holger Ophoff was, in the light of precautionary principle, by what time dimension do you consider history of safe use? 10 years, 30, 10,000? Difficult question, I must say.
Yes, indeed, it's a very difficult question. Now, when you talk about the history of safe use, this is a question about a period of time. And the first problem is, what is the starting point for that period of time? Is it the first use in a laboratory, or is it the first use in a field trial, or is it first use in cultivation on a commercial scale? So that's one problem. Another problem regarding the question, what is the period of time that constitutes a history of safe use, is what are the scientific uncertainties? Do we have to start from scratch with regard to science, or is there already sufficient scientific knowledge so as to assess what could happen if we make use of this or that technique? And then also, I think the period of time for history of safe use depends on the kind of risks we are talking about. Do we talk about risks to human health, or do we talk about risk to the environment? I mean, the environment is very important as well, but if you talk about risk to human health, foodborne risk, for example, I think we should be, of course, very careful. And this would call perhaps for a longer period of time that could constitute a history of safe use. And another issue could be, for defining that period of time, the principle or concept of substantial equivalence. So if there is a new organism derived from genome editing, but this is substantially equivalent to an organism derived from traditional mutagenesis, that may call for a shorter period of time that constitutes the history of safe use, because looking into the past and all the experience we gained in the past with regard to the organism derived from traditional mutagenesis, that may suffice to assess the safety of that organism. So I cannot give you any number, any concrete number. It's 10 or 30 or 10,000 years. It may be 10 years only. It may be 30 years. But for sure, it's not 10,000 years.
Thank you very much. As a biochemist, I would like to add that it depends also the frequency, how often it is used, and it's very often used. You know, if you use it only once every 100 years, of course, it might be longer. But this technology is used by thousands of laboratories at the moment, so it's really also the frequency. I would like to continue. There is one question from Astrid Österreicher, and I don't get it perfectly, but I think it's a complex question, but I would like to frame it, and maybe also Professor Dederer and Professor Klein. It's addressed to Professor Klein, actually, sorry. And now I got it, what a bit difficult. Do you think, from an ecological perspective, that the statement by Leopoldina and DFG sufficiently reflect upon risks that new genomic techniques might pose? First part of the question.
Yeah, I think that I read the question actually earlier because it came up really early. I think it's mainly if I think there will be environmental risk in the end. I think from my perspective, of course, if we have a new genotype, there is a risk. But this risk is also there with a common breeding program.
Yes.
The only difference I see is that we have a new technique that is much faster, that is more precise. So this has, of course, advantages, but might bring also more risk. But we have no research on that. I don't see any research on this. So I would argue we should start doing more research in all of these directions. Not forever, but we need, of course, especially from the ecological point of view, because in former times, in all of these discussions, ecologists were mainly not included, I think. So I think we should...
I want only to broaden your statement.
Okay. But can I hope I have answered this. Can I make a point from my side? So when I look at our research, I really have a problem in having this black and white discussion, organic and conventional. And no GMOs in organic, but in conventional and IP we have. I think we need to broaden this. I really think we need new categories. Why not having a category with organic that has genome editing as a new category? Or why not organic that really uses no pesticides at all, because we using biological pesticides in organic. From our data, I see such a variation. We have a really good organic growers. They have high biodiversity and high yield, but we also have this on the conventional side. So I find this really hard to go with these black and white discussions.
But I think this is the reason also, I hope, why we are sitting here. Yes. Pablo, please, you just raised your hand, please.
Yes, I did. I want to see if I could have a little input since I didn't get any questions. No, I on the last question, I believe Alexandra stated it correctly when she mentioned that these new plant breeding techniques are more precise, less costly, and can be done in a faster way. But I'd like to tie it with what Professor Dieter mentioned about substantial equivalence. And when we're talking about the risk to the environment, if you have an end product that is substantially equivalent to one that has been produced through conventional breeding, then the risk that you should apply to it should be equal. And I think Professor Dieter also talked about this when he talked about the precautionary principle and how constant it needs to be. So I guess I wanted to chime in a little bit on the risk assessment and how a regulation can be risk-based.
Yeah, thank you very much. I think we need to come to close soon because we are just over time, and we have still a number of questions, I must say. And now also answers to the questions from in between. There's maybe one also to Professor Klein also, maybe just one last question if I could. It says, could the reduced production of organic farming be in part solved by a better distribution of agricultural productions?
Of course, I don't have any research on this, but this seems to be very logically. It's also, we need to produce less waste. We have too much food waste, and yes, of course.
But may I also add at the end something as microbiologist, there's really very interesting studies showing that, for instance, the infection of crops, and there's only, I think, 10 or 12 plants we use on the whole earth to get our nutrition from, that the infection by fungi destroys some of these harvests by 50%. And this also has a direct effect of the climate change, by the way, it's also a very interesting aspect, of course, which we cannot discuss here. Okay, I would like to close at this point. What we have learned today, I think, and this was very interesting to me also to see the different opinions. We have learned that, let's say, when we start again from Pablo, that in the developing world, it appears to be a technology, at least what you said, which appears to be very important there. At least it is seen as very important for the future of nutrition. We have learned from Dr. Messmer that, of course, there is a strong tendency also to organic, to solutions by using the organic agriculture. The question then, of course, which we discussed also, is whether we can feed the whole mankind with this solution. We have learned from Professor Dedra, and thank you very much for stepping in. Also, what I found very interesting, because I'm not a lawyer at all, about the precautionary principle, and that it always needs to be a balance between benefit and risk. And what I've learned from you, what I liked, is that also this needs to include what is happening when you do not use the benefit. So it's not only in case that you use it, but what happens when you do not use it. And this is what I've learned. And of course, also Professor Klein, thank you very much for your perspective also to show us the ecological perspective. I think is very important. And also that I think it might not be related. I hope no, I do not interpret, otherwise shout at me. It is a systematic problem of agriculture and is not related really to the use of the technology. Can I say that? I think so. Only technology, you know. Okay. With this also, of course, to the audience, and I'm really sorry, we had a lot, it was a very interesting session and we had a lot of questions and I could only pick a couple of them because there were just too many. Thank you very much to all of you for listening and to joining us. And tomorrow we will continue, and I hope to see you all tomorrow morning. Thank you very much. Thank you for you.